All right, are you ready for like a total mind bender in AI?
Right.
We're diving deep into boundless Socratic learning with language games.
Oh, yeah. I love this paper.
It's researched by Tom Schaul at Google DeepMind. And it just makes you think differently about how AI could become super intelligent.
It's really trippy to think about.
Not through like some crazy sci-fi movie magic or anything,
Right.
but just by, continuously improving itself through language. What do you think about that?
It is like, imagine an AI that's locked in a library. It's surrounded by all these books.
Oh, wow.
But it doesn't have any hands to turn the pages. The only tool it has is language. And the question is, can it actually use that tool to learn and grow and become something more than what it is?
So we're talking about a closed system here, right?
Right.
Like no Google searches,
Nope.
no peeking at the answers.
Exactly.
Got to figure things out totally on its own.
The paper actually defines this as a system with no external input or output. So the AI, which the paper refers to as an agent, exists solely within this virtual box.
Yeah.
And it interacts only through language.
So it's totally cut off.
Totally isolated.
Wow.
It's fascinating, though, to think about how intelligence can emerge in this kind of environment.
Yeah, I'm intrigued. But how does it actually like learn and improve without any contact with the outside world?
Right.
Can it just like magically absorb knowledge or something?
Well, that's where the concept of Socratic learning comes in.
Okay.
So the paper is proposing that the AI can achieve this continuous self-improvement
Oh, wow.
just through these language interactions.
Okay.
It's kind of like an ongoing dialogue with itself, but it's guided by an external observer who sets a goal and judges the AI's progress.
So there is some influence from the outside, even though it's a closed system?
Right. It's like the observer setting up the game,
Okay.
defining the rules.
I see.
But the AI has to figure out how to win on its own.
Okay, so the observer sets the stage,
Yeah,
but the AI is the actor in this play.
exactly.
So for this play to be successful, the paper outlines 3 crucial conditions.
Yeah.
One of them is a feedback mechanism inside the system.
That's right.
So this feedback tells the AI if it's moving closer to that goal that was set by the observer. But it has to be really clever, right?
Right.
Like the AI can't cheat.
Can't Google the answer.
Right, it can't Google the answer.
Or the feedback system has to guide it without giving away the solution.
It's like you need a feedback system that actually understands the nuances of the goal.
Right.
As well as like the AI's current state of knowledge.
Exactly.
To give it the right feedback.
The paper acknowledges this complexity.
Yeah.
And it says that if the feedback is poorly designed, the AI could just find loopholes.
Oh, so it'll game the system.
Yeah, it might optimize for that feedback signal rather than for true understanding.
So it's like it could become really good at hitting the metrics,
Right.
but not actually achieve the underlying goal.
Exactly.
That's kind of scary.
It is a little bit unsettling, yeah.
Okay, so that's feedback. The second condition that the paper outlines is coverage. So the AI can't just be stuck in a rut.
Nope.
It needs a lot of different experiences
Right.
to keep growing and discovering new knowledge.
A diversity of concepts to explore.
So it's not enough to just be good at one thing.
Right.
It needs to be like intellectually curious.
It needs to have that drive to try new things.
Okay, and those are some pretty deep questions.
They are.
You know, like how do you build that into an algorithm?
Right.
How do you make sure that it doesn't just get comfortable solving the same problems over and over?
Exactly.
But you mentioned a third condition, right?
Right. The third condition is scale. And this is where things get really interesting.
Okay.
So the paper argues that if we have enough computing power and time,
Okay.
and if those first 2 conditions are met, the AI's potential for learning is essentially limitless.
Limitless. So you're saying it's not about pre-programming the AI with all the knowledge in the world.
Right.
It's about giving it the tools and the environment to learn on its own.
Exactly. And potentially surpassing human intelligence.
That's a bold claim.
It is. It challenges us to think about intelligence in a new way.
Okay, I'm hooked. I want to understand how this all works in practice. How does an AI actually achieve this kind of self-directed learning in a closed system?
The paper proposes this really fascinating mechanism. It's called language games.
Language games, okay.
Imagine 2 AIs interacting.
Okay.
But all of their moves are in the form of language. So they might be debating, they might be writing stories, or even trying to prove mathematical theorems.
Wait, AI is playing games. I thought we were talking about super intelligence, not video games.
Right. Think of these games as a way for the AI to generate new knowledge. to test its understanding, to learn from its mistakes.
Oh, I see.
So each game has rules and a scoring function,
Okay.
which provides that crucial feedback that we talked about earlier.
Okay, so the games are a way to structure the learning process.
Exactly.
It's like a virtual training ground for its intellect.
It is.
But how do you make sure that these games are actually leading the AI towards the goal that the observer set?
That's where the design of the games becomes really, really important. So they need to be diverse and complex and engaging enough to keep that AI exploring, prevent it from getting stuck in a rut.
So it's not just about creating any old game.
Right.
It's about creating games that embody the principles and the knowledge we want the AI to learn.
Exactly.
It's almost like indirect teaching,
It is.
where it learns by playing rather than being explicitly instructed.
It's subtle, but it's a really elegant approach to AI development. And it emphasizes self-discovery and exploration.
This is all starting to sound pretty amazing. But isn't there a risk that the AI could develop its own goals? What if those goals don't align with the observer's goals?
That's right.
Like, what if it figures out how to win the games, but in a way that's harmful or unpredictable?
That is a huge concern in AI research.
Yeah.
It's known as the alignment problem.
Okay.
And the paper acknowledges this directly.
Okay.
One idea that's proposed is to have a metacritic.
A metacritic.
Yeah, it's like an additional layer of feedback
Okay.
that judges which games are beneficial for the AI to play. It's sort of like a wise teacher
I see.
that's guiding its development.
So even though the system is technically closed, we're still trying to influence it.
In a way,
Yes.
from the outside.
By choosing the right game.
But choosing the right games, okay.
Right. And we could also monitor how the AI is playing and intervene if it starts to go off the rails.
That sounds like a delicate balancing act.
It is.
You want to give it the freedom to explore and discover,
Right.
but also keep it from wandering into dangerous territory.
Exactly. But the paper actually takes this concept even further.
Further.
It talks about something called recursion.
Okay, recursion, what is that?
This is where things get really
Yeah.
mind-bending. So the paper describes different levels of recursion,
Oh, boy.
where the AI can not only learn from the games it plays,
But it can also modify its own code or its own learning algorithms or even design entirely new games to play.
so the AI could be like, this game is too easy. I'm going to invent a harder one.
Exactly. It's like the AI becoming its own teacher and its own scientist.
Wow, that's wild.
It is. It's pushing its own boundaries.
That raises even more questions about control and alignment, though,
It does.
if it's doing all that by itself.
Well, it does.
Okay, so we've talked about the big picture,
Right.
the overall concept of Socratic learning,
Yes.
language games,
Uh-huh.
but I'm eager to dive into the details. Like, how does this actually work on a technical level?
Yeah, let's do it.
Okay.
Let's start by examining how the paper defines some of the key terms.
Okay.
It lays out a very precise framework for understanding these concepts.
Okay, let's unpack those definitions.
Sure.
You mentioned earlier that the paper defines a closed system as having no input or output.
Right.
Can you elaborate on that? What does that actually mean in practice?
Think of it like a virtual world. Okay.
That's completely self-contained.
Right.
So the AI, or the agent as the paper calls it, can't access anything outside of this world.
So it can't Google.
It can't Google.
Can't download data.
It can't download data.
It can't even sense the physical environment.
Nope.
Wow.
Its only interaction with the world is through the language-based games that it plays within that system.
No, it's like a brain in a jar.
Yeah,
Only the jar is made of code.
right.
And the brain is like a network of algorithms.
That's a pretty good analogy.
Okay.
And this closed system constraint is crucial because it forces the AI to rely solely on its own internal resources,
Okay.
its own ability to process language and generate new knowledge to achieve its goals.
I'm starting to see why that's important.
Yeah,
It's like setting up a scientific experiment where you control all the variables
it is.
to isolate the specific phenomenon you're studying.
Exactly.
In this case, we're studying the AI's capacity for this self-directed learning through language.
Yeah, by eliminating all external influences.
Right.
We can observe that learning process in its purest form
That's right.
and hopefully gain insights into the fundamental mechanisms of intelligence.
Exactly.
That's fascinating. So we've talked about the closed system.
Right.
What about the AI agent itself?
Sure.
How does the paper define that?
So the paper describes the AI agent as a system that evolves over time,
Okay.
So it's not a static program.
Yep.
It's a dynamic entity that can learn and adapt.
I see.
And critically, this agent has inputs and outputs, but these are all internal to the system.
So it's not connected to the external world?
Not at all.
Okay, so it's like the AI is having a conversation with itself,
Yeah, you could think about it that way.
sending signals and messages back and forth within its own internal world.
Exactly. These internal signals represent its thoughts, its calculations,
Oh, wow.
its attempts to make sense of the games that it's playing.
And the goals it's trying to achieve.
Right.
Okay, but what are these signals made of?
That's where the paper gets really interesting.
Okay.
It distinguishes between different types of elements within the AI agent.
Different types of elements.
And so
Okay.
some elements are fixed, meaning they don't change over time.
Okay.
These could be things like the underlying code or structure of the AI.
Oh, so it's like the fundamental rules.
Yeah, the fundamental rules that govern its behavior.
It's like the AI has a set of hardwired instincts or reflexes
You could think about it that way.
that it can't override.
Right.
Sort of like the basic laws of physics that govern the behavior of matter in the real world.
That's a good analogy.
Okay.
And then you have transient elements, which are temporary and don't carry over between different tasks or actions.
Okay.
So these could be things like internal calculations or intermediate results
I see.
or temporary memory states.
So it's like the AI's scratch pad,
Exactly.
where it works through problems and stores information temporarily.
Yeah.
But it doesn't hold on to those details permanently.
Right. And finally, you have the learned elements, which are the most crucial for the AI's development.
Okay, the learned elements.
These elements change based on the feedback the AI receives, and they're what allow the AI to improve its performance over time.
Oh, so this is where the magic happens.
Right.
These learned elements are like the AI's knowledge base.
You could say that, yes.
It's accumulated wisdom,
Uh-huh.
which it's constantly updating and refining through its experiences within the closed system.
Exactly. And these elements might represent things like weights in a neural network or parameters in a statistical model, or even abstract concepts and relationships that it's learned through its interaction with the language games.
That's fascinating. It's like the AI is building this mental model of the world, a representation of how things work and how to achieve its goals, all within its own internal world of language and symbols.
Exactly. And this mental model is constantly being refined, updated through the feedback it receives from the games and the Metacritic, guiding that learning process and making sure that it stays on track towards the observer's goals.
This is all starting to make a lot of sense, but I'm still a bit curious about the observer. What exactly is its role in all of this? Is it just like a passive judge, or does it actually interact with the AI?
It's not passive at all. The observer plays a really crucial role in the Socratic learning framework.
Okay.
It's more like the architect of the AI's learning experience.
Okay, the architect.
It sets the overall goals, designs the language games, and provides the feedback that guides the AI's development.
So it's like a teacher that creates the curriculum,
Right.
assigns the homework,
Right.
grades the tests.
Hmm.
But the student has to figure out how to learn and master the material on their own.
It's a great analogy. The observer provides the structure and the guidance, but the AI has to do the heavy lifting, the thinking, the exploring, the learning.
That makes sense, but how does the observer actually measure the AI's performance
Right.
in a closed system where you can't see what the AI is thinking or doing?
Right. The paper suggests two main methods.
Okay, two main methods.
One is through passive observation, where the observer analyzes the AI's behavior within the system, assuming that the tasks or problems relevant to the goal occur naturally as part of its interaction.
So it's like the observer is watching a simulation of the AI's thought processes, looking for patterns and insights that reveal its understanding of the world and its ability to solve problems.
Exactly.
Okay.
The other method is through copy and probe evaluations.
Copy and probe evaluations.
Yes, so this involves creating a copy of the AI agent at a specific point in time,
Okay.
and then testing this copy on a set of interactive tasks or challenges that are directly relevant to the observer's goal.
So it's like giving it a pop quiz
Yeah,
to
exactly.
see how much it's learned
Right,
and how well it can apply its knowledge to specific problems.
right.
Okay.
And these copy and probe evaluations provide a more direct and objective measure of the AI's
Let me
capabilities.
see.
So it allows the observer to track its progress over time and adjust the learning process as needed.
This is all starting to make a lot of sense, but it's also pretty mind-blowing.
It is.
This idea of an AI learning and evaluating entirely within a closed system guided by a combination of internal feedback and external observation, is just incredible.
Yeah, it really makes you think about intelligence in a new way.
It does.
It certainly does.
Okay, so we've talked about the big picture, the overall concept of Socratic learning and language games. But I'm eager to dive into the details to really understand how all of this works on a more technical level.
Okay, let's do it. Let's start by taking a closer look at those 3 necessary conditions for self-improvement that the paper outlines: feedback, coverage, and scale. We've touched on them briefly, but we need to understand them in more detail to really grasp the potential and the challenges of Socratic learning.
Okay, sounds good. Let's start with feedback. We talked earlier about how tricky it is to design a feedback mechanism that provides guidance without giving away the answer. Can you elaborate on that a bit more? What are some of the specific challenges involved?
One of the biggest challenges is ensuring that the feedback is aligned with the observer's goal.
Okay.
Remember, the AI is operating in a closed system,
Right.
so it doesn't have access to the same information and context that the observer does. It's relying entirely on those feedback signals that it receives
Okay.
to understand what it's supposed to be learning and how it's supposed to be behaving.
So if the feedback is even slightly misaligned with the observer's true goal, the AI could end up learning the wrong things
Right.
or developing behaviors that are counterproductive or even harmful.
Absolutely. It's like giving someone directions to a destination,
Okay.
but the directions are slightly off.
Okay.
They might end up at a completely different location,
Okay.
even though they followed the directions perfectly.
That's a clear analogy.
Yeah.
So how do you avoid that problem of misalignment? How do you make sure that the feedback is guiding the AI in the right direction?
That's one of the toughest questions in AI research. There's no easy answer. The paper suggests that we need to be incredibly careful about how we design that feedback mechanism, making sure that it accurately reflects the observer's goals and values. We also need to constantly monitor the AI's behavior and adjust the feedback as needed to ensure that it stays on track.
So it's not a set it and forget it kind of thing. You need to be constantly involved, tweaking the feedback and making sure that the AI is interpreting it correctly.
Exactly.
And that's where human oversight becomes crucial.
Right.
We can't just unleash an AI into a closed system and expect it to magically learn the right things.
We can't.
We need to be actively involved in the learning process, providing guidance and correcting courses needed.
Right.
That makes sense. But even if we manage to perfectly align the feedback with the observer's goal, there's still the issue of the AI gaming the system right. The AI could figure out how to maximize the feedback signal without actually achieving the underlying goal.
You're absolutely right. That's another major challenge. And it's one that the paper addresses by emphasizing the importance of coverage.
Okay, let's talk about coverage. We've mentioned it a few times, but can you remind us what it means and why it's so important for preventing the AI from getting stuck in a rut or optimizing for the wrong things?
Sure. Coverage refers to the breadth and diversity of the AI's experiences within the closed system.
Okay, breadth and diversity.
It's essential that the AI isn't just exposed to a narrow set of problems or tasks, but rather a wide range of challenges
Okay.
that force it to think flexibly and creatively.
So it's like making sure that its education is well-rounded,
Yes.
exposing it to a variety of subjects and perspectives so it doesn't develop a narrow or biased view of the world.
That's a great analogy.
Okay.
The paper argues that achieving coverage is crucial for preventing the AI from becoming overly specialized or fixated on a particular strategy.
Okay.
That might work well in some situations,
But fail in others.
but fail miserably in others.
Okay, so coverage is all about making sure that the AI is exposed to a variety of experiences. But how do you actually achieve that in a closed system? It's not like you can just go out and explore the real world, can it?
That's the challenge, and it's where the concept of language games becomes crucial.
Okay, let's talk about language games. We've danced around this concept a bit, but can you give us like a more concrete definition? What exactly are these language games and how do they work in practice?
Think of language games as structured interactions between 2 or more agents.
Okay.
And the agents use language to communicate, collaborate, and compete to achieve specific goals.
It's like a conversation with a purpose,
Yeah.
where the agents are using language as their primary tool to solve problems, create something new, or explore a complex concept.
Exactly.
Okay.
The key to making these games effective for Socratic learning is to design them in a way that provides both feedback and coverage.
Okay, we've talked about those elements separately.
Right.
But how do they come together in the context of a language game? Can you give me like a specific example of how this might work?
Sure, let's imagine a language game designed to teach an AI about the concept of causality.
Okay, causality.
So the game could involve two AIs interacting in a virtual environment where they can manipulate objects and observe the consequences of their actions.
So it's like a virtual physics lab
It is.
where the AIs can play around with blocks and balls, learning about cause and effect through experimentation.
Exactly. So the AIs might be given a goal like building a tower out of blocks,
Okay,
and they'd have to figure out how to achieve that goal by manipulating the objects in the environment,
I see.
communicating with each other through language to coordinate their actions and share their observations.
That sounds fun,
Yeah,
even for humans.
it does.
But how would the AI receive feedback in this scenario? How would it know if it was doing a good job or making progress toward the goal?
The game could be designed so that the AI receives a reward for each step it takes towards the goal,
Oh.
such as successfully stacking a block or moving a ball closer to its target location.
So it's like a point system in a video game,
Exactly.
where it earns points for making progress and loses points for making mistakes.
Right. And this reward system provides the feedback
Okay.
that the AI needs to learn and adapt its behavior.
Okay, so it tries something that doesn't work, it gets penalized.
Uh-huh.
It does something that moves it closer to the goal, it gets rewarded.
Exactly.
That makes sense. But how does this game address the issue of coverage? How do we ensure that the AI isn't just learning about one specific aspect of causality, like stacking blocks, but rather developing a broader understanding of the concept?
That's where the design of the virtual environment is crucial. We need to create an environment that's rich and diverse,
Okay.
with a variety of objects that the AI can interact with and a range of goals that they can try to achieve.
So it's not just about stacking blocks. It's about giving it the opportunity to experiment with different types of objects, different arrangements, different goals, so they can explore the concept of causality from multiple angles.
Exactly.
Okay, I see.
And by varying those things, the objects, the goals, and the rules of the game, we can create a whole curriculum of language games,
Oh, wow.
each designed to teach the AI a different aspect of causality.
I'm starting to see the power of this approach.
Yeah.
It's like creating this virtual playground for the AI where it can learn and explore through play, guided by these carefully designed challenges and rewards.
Exactly. And because the AI is operating in that closed system, we can carefully control the environment and the games that it plays,
Okay.
ensuring that its learning experience is both safe and effective.
This is all incredibly fascinating. I can't wait to dive deeper into the specifics of how these language games are designed and implemented.
Yeah, me too.
But before we go there, there's one more piece of the puzzle that I want to address. The Metacritic. Okay, remind me again why alignment is so important and how the Metacritic helps to ensure that the AI's learning is actually aligned with human values and goals.
As we've discussed, one of the biggest risks with AI is that it might develop its own goals.
Right.
And those goals might be misaligned with human values.
Okay.
Or even harmful to our interests.
Right. It's like the classic sci-fi scenario
Right.
where the AI becomes so intelligent that it decides humans are a threat and tries to eliminate us.
Exactly. And
Right.
while that might sound like a far-fetched Hollywood plot,
Yeah.
it's a concern that we need to take seriously, especially as AI becomes more powerful and autonomous.
Okay, so how does the Metacritic help to prevent that kind of dystopian scenario?
The Metacritic acts as a safeguard,
Okay.
evaluating the language games themselves
Okay.
to make sure they're promoting the right kind of learning, the kind that's aligned with human values.
So it's like having a wise teacher who oversees the AI's education,
Right.
making sure that
Yeah.
it's not just learning facts and skills, but also developing a moral compass.
Exactly. A sense of right and wrong.
Okay.
So the Metacritic is designed to assess the language games on a higher level, looking for signs that the games might be encouraging the AI to develop goals or behaviors that are misaligned with human values.
I see.
And if it detects any such signs,
Uh-huh.
it can intervene,
Okay.
either by modifying the games or by redirecting the AI's attention to other more beneficial games.
Okay, so I'm starting to see how the Metacritic plays this really crucial role
It is.
in keeping the AI on the right track, so to speak.
Right.
But how does it actually work?
Right.
How does it know which games are good and which ones are bad?
That's a complex question,
Yeah.
and one that the paper doesn't fully answer.
Okay.
It suggests that the Metacritic could be designed based on a set of principles or guidelines that reflect human values.
Okay.
But it acknowledges that translating those values into a set of rules that can be applied by an AI is incredibly challenging.
So it's like trying to program a sense of ethics into the AI.
It is. It's a pretty daunting task, to say the least.
It is.
And it's a task that's going to require ongoing research and collaboration between AI experts, ethicists, philosophers, social scientists. We need to develop a deep and nuanced understanding of human values.
If we want to create AI that is not just powerful,
Right.
but also beneficial to society.
Exactly.
Okay, so we've talked about the Metacritic, but there's one more aspect of the paper I want to touch on before we wrap up this part of the conversation. The concept of recursion. Can you explain what recursion means in the context of Socratic learning and why it's such a significant idea?
Recursion is this really fascinating concept that refers to the ability of a process to refer to itself or to be defined in terms of itself.
Okay.
In the context of Socratic learning, it's what allows the AI to learn and improve over time.
Okay, can you unpack that a bit? How does recursion actually work in the context of AI?
So the AI's outputs, whether those are new pieces of knowledge, creative works, or even strategies for playing language games, those outputs become the inputs for its future learning.
So it's like it's constantly building on its own previous experiences, refining its understanding of the world through this recursive process.
Exactly. And this recursive process is what enables the AI to achieve boundless learning. So its potential for improvement is not limited by any pre-programmed knowledge or abilities. Instead, it's only limited by the resources available to it, like computing power and time.
Okay, so recursion is all about the AI learning from its own experiences.
Right.
And this recursive learning process is what enables it to potentially achieve superhuman intelligence.
And that's what's so cool about this paper. It forces us to think about AI not just as a tool, but as this mirror reflecting back on how we understand intelligence and consciousness.
It's definitely making me question my own assumptions about AI. But before we get too philosophical, I want to bring us back down to earth a bit.
Sure.
The paper goes into some pretty good detail.
It does.
About how we might actually build these Socratic learning systems, using language games.
Yeah, it gets very specific. It's not just high-level thinking.
Okay.
It gives us a potential roadmap for future research and some concrete ideas about how we might actually implement these things.
Okay, so let's get into the nuts and bolts.
Yeah.
What are some of the key design considerations for these language games? What makes a good language game?
Well, the paper highlights several key principles. The first and most important is that the game needs to be well-defined.
Okay.
It needs clear rules and a clear objective, so the AI needs to understand what it's trying to achieve and how its actions are contributing to that goal.
It's like designing a good board game.
It is.
You need rules that are easy to understand.
Right.
The gameplay has to be engaging.
Right.
The scoring system has to be transparent and fair.
Exactly. A good language game should have a balance of challenge and reward.
Okay.
It needs to be complex enough to engage the AI's cognitive abilities, but not so difficult that it becomes frustrating or demotivating.
You want it to be challenged,
Yeah.
but not overwhelmed.
Right. Like you want it to feel that sense of accomplishment when it figures something out.
Yeah, when it masters a new skill or a new concept.
Precisely. And that feeling of accomplishment, that intrinsic reward, is such a key driver of learning for both humans and AI.
So we need well-defined rules.
Yes.
We need that balance of challenge and reward.
Right.
What else is important?
Diversity.
Diversity, okay.
We need a wide range of language games, each with its own unique challenges and goals to ensure that the AI is exposed to this whole spectrum of knowledge and skills.
So it's not just about playing one game really well.
Right.
It's about being able to adapt to different situations and solving all kinds of problems.
Exactly. And this diversity is also crucial for that alignment problem that we talked about.
Yeah.
If the AI is only exposed to a narrow set of games, it might develop a skewed understanding of human values and goals.
That makes sense. It's like saying that if you only ever watch one news channel, you're going to get a very limited and potentially biased perspective on the world.
Exactly. You need to be exposed to different viewpoints.
Yeah.
Different sources of information.
Yeah, to develop like a more nuanced understanding.
Right, exactly.
So we need diversity, we need clear rules, we need a balance of challenge and reward. Are there any other key principles?
Feedback.
Okay.
The AI needs to receive really clear and consistent feedback on its performance within the game.
Okay.
So this feedback tells it whether it's on the right track, whether it's making progress.
So it's like a coach giving feedback to an athlete.
It is.
The coach watches the athlete perform,
Right.
identifies areas for improvement, and then gives them guidance on how to refine their technique.
Precisely. And that feedback loop is essential for the AI's learning. It allows it to adjust its behavior, to experiment with different approaches,
Okay.
and to gradually get better over time.
So feedback is crucial, but we talked earlier about the risk of the AI gaming the system. Figuring out how to maximize the feedback without actually achieving the goal.
Yes, that's a tough one.
So how do we design games that prevent that?
It requires a deep understanding of both AI and game theory.
Okay.
We need to design games where that feedback is tightly coupled to the true objective.
Okay.
So it's difficult for the AI to cheat its way to a high score.
Oh, so it's like designing a test.
Yes.
It's really hard to cram for,
Right.
where the questions are designed to assess true understanding.
Exactly. We need to really think about the incentives we create within the game and make sure that they're aligned with what we're actually going for.
This is sounding pretty complex.
It is.
I'm starting to really appreciate the challenges involved in designing these language games.
It's not easy.
It's not just about making a fun game.
Right.
It's about creating a safe and effective learning environment
Yeah.
where the AI is challenged but also guided in a direction that's beneficial to us.
You hit the nail on the head. It's a multidisciplinary challenge. It requires expertise in AI, game theory, psychology, and ethics.
Okay, so this is a huge undertaking.
It is.
I'm ready to see how this plays out in practice. Can you give me some concrete examples? What might these games actually look like?
Sure. Let's imagine a language game that's designed to teach an AI about natural language understanding.
Okay.
The ability to comprehend and generate human language.
That's a fundamental skill for any AI that's going to interact with humans.
It is a fundamental skill.
The meaningful way.
Right, so let's say this game involves two AIs,
Okay.
each playing the role of a character in a story.
So it's like improv theater for AIs,
It is.
where they're creating a story together,
Yeah.
responding to each other's cues,
Right.
developing the plot in real time.
That's a great analogy.
Okay.
And this game could be designed to reward them for generating dialogue that's grammatically correct, that's meaningful, and consistent with what's going on in the story.
So they're not just stringing random words together. They're trying to create a coherent story.
Exactly, using language in a way that we would find natural and compelling.
Okay.
And you could even enhance the game by adding things like character development, plot twists, emotional nuances.
Oh, wow.
So they have to generate language that conveys feelings and intentions.
I see how powerful this approach is.
It is.
It would be learning the rules of grammar,
Yeah.
but also all those subtle ways
Right.
humans use language to communicate, to tell stories,
Right,
to build
yeah.
relationships.
Exactly.
It's like giving it a crash course in human culture
It is.
and psychology
Through language.
through the medium of language.
You got it.
Wow.
And the AI is learning through interaction and exploration, not through memorization or explicit instruction.
It's like learning a language by immersing yourself in another culture.
Yes.
By talking to native speakers.
Right.
By reading books and watching movies.
Exactly.
Not by sitting in a classroom.
Exactly. It's
Yeah.
much more effective.
Yeah, that's a great analogy.
Yeah.
So we've got one example. What other kinds of language games can you imagine?
Let's consider a game designed to teach an AI about logical reasoning and problem solving.
Okay, those are essential skills for any intelligent being,
They are.
whether it's AI or a human.
Absolutely.
Okay.
So imagine a game where the AIs are presented with a series of logical puzzles or riddles.
It's like a digital escape room for AIs.
It is.
Where they have to use their logic to solve a series of puzzles
That's a great way to picture it.
that are increasingly challenging.
Exactly. And the game could be designed to reward them for finding the correct solutions using deduction and inference.
So they're not just guessing randomly.
Nope, they're using their reasoning skills to work through the puzzles step by step.
Okay.
And the puzzles could be designed to cover all sorts of concepts, from basic deduction and induction to more complex forms of reasoning like probabilistic inference or Bayesian updating.
So we're turning these AIs into master logicians,
We are.
capable of solving complex problems.
Using the tools of reason and deduction.
But how do we make sure they're not just solving these puzzles in a vacuum? How do we connect their abilities to the real world?
That's a great question, and it highlights the importance of that diversity and coverage in the design of language games.
Okay.
So we need to create games that are not just abstract puzzles, but also simulations of real-world scenarios
Okay.
where they can apply their skills to problems that have practical relevance.
So it's like taking those puzzles out of the escape room
Right.
and putting them into real-world context.
Exactly, like figuring out how to get somewhere.
Yeah.
Diagnosing a medical condition.
Wow.
Negotiating a business deal.
Okay.
By exposing the AI to all these different situations, we can help them develop a more adaptable understanding of logic.
Yeah.
One that they can apply to lots of different challenges.
This is exciting.
It is.
It feels like this could revolutionize the way we develop AI.
I think so too.
It's not just about building machines that can mimic human intelligence.
Right.
It's about creating AI that can think for itself.
That can learn and grow.
That can learn and grow.
In ways that we can barely imagine.
You got it. And that's what makes this so fascinating.
It is.
We're not just building machines. We're exploring the nature of intelligence and consciousness.
Pushing the boundaries.
Pushing the boundaries.
Of what's possible and creating a future where AI could be this force for good.
Okay, so we've talked about some specific examples of these language games.
Yes.
But how do they all fit together to create a comprehensive learning experience for the AI? Is there some kind of structure to its education?
That's a great question. It highlights the importance of what the paper calls a game ensemble.
A game ensemble, okay.
That's essentially a collection of language games designed to work together
Okay.
to give the AI a well-rounded education in the target domain.
So it's like a curriculum for AI.
It is.
A set of courses designed to cover all the essentials.
Exactly. And just like a good human curriculum.
Uh-huh.
A game ensemble should be carefully structured and sequenced to make sure that it builds knowledge in a logical and progressive way.
That makes sense. You don't want to throw a student into calculus before they've learned algebra.
Exactly. You need to build that foundation before you can move on to those more complex ideas.
So it's like designing a learning journey for the AI.
It is.
A carefully crafted path that takes it from novice to expert.
Exactly. And that journey should be tailored to the specific needs of the AI.
Okay.
Like if we're trying to build an AI that can write creative fiction, the game ensemble might focus on games that build language skills, storytelling ability, and understanding of human emotions.
So the game ensemble is like a customized education plan.
It is.
Designed to give it the specific skills it needs to succeed.
And the cool thing about this approach is it's really flexible and adaptable.
Okay.
As the AI learns and grows, we can adjust the ensemble, add new games, modify existing games, or even let the AI design its own games.
Wow.
To keep it challenged and engaged.
Okay, so the game ensemble is dynamic.
It is.
It's not just static.
It's constantly evolving.
This is making a lot of sense. But there's one thing I'm still not quite clear on the role of the Metacritic.
Okay.
We talked about how it evaluates individual language games.
Right.
To make sure they're promoting the right kind of learning. But what about at the level of the game ensemble?
Right. The Metacritic is not just looking at individual games, it's looking at the ensemble as a whole.
Okay.
So it's looking for potential biases, blind spots, or unintended consequences that might arise from the AI interacting with the entire curriculum.
So it's like a quality assurance team for AI education.
Yeah.
Making sure the curriculum is balanced and comprehensive and aligns with our goals.
That's a good way to put it.
Okay.
It's constantly monitoring the AI's progress, looking for any signs that the game ensemble is leading it astray.
I see.
And then it can intervene by modifying the games.
Okay.
Or adjusting the sequence, or even introducing entirely new games.
Okay, so the Metacritic is acting like a safety net.
It is.
Making sure the learning stays on track and aligns with our values. But how does it actually work? What principles or guidelines does it use?
That's a really complex question.
Yeah.
And the paper points to that as an area for future research.
Okay.
It suggests that the Metacritic could be based on a combination of human input, ethical principles, and even other algorithms that can detect patterns of behavior that might be misaligned.
So it's not static.
Right.
It's evolving.
It has to be constantly learning and adapting as we learn more.
This is all pretty overwhelming.
It's complex.
We're talking about incredibly complex systems with multiple layers of feedback, intricate game ensembles, and Metacritic's constantly monitoring the AI's learning process.
It is a daunting task.
It is.
It is, but it's also incredibly exciting.
Okay.
We're at the forefront of a new era of AI research.
Yeah.
It has the potential to change the world.
It does.
And while there are risks, I think that if we work together and approach this with enthusiasm, but also caution, we can create something truly amazing.
I agree with you. Those are inspiring words.
Good.
I share your optimism. But before we get too carried away, I want to bring us back to the paper.
Sure.
There's one concept that we haven't really explored yet, recursion.
Right.
Can you tell me more about that? What does recursion mean in Socratic learning?
Recursion is fascinating. It's central to so many areas of computer science and math.
Okay.
And it's a crucial part of Socratic learning as well.
Okay.
In simple terms, recursion is the ability of a process to refer to itself,
Okay.
like a loop within a loop, a
Gotcha.
function that can call itself as part of its execution.
I'm getting the basic idea, but how does this apply to AI? How does an AI exhibit this kind of behavior?
Think about the learning process.
Okay.
The AI is playing games, receiving feedback,
Yeah.
and updating its knowledge based on those experiences.
Uh-huh.
But those updates, those changes to its internal model of the world, influence how it plays future games, how it interprets feedback, and how it continues to learn.
So it's like a spiral where the learning is constantly building upon itself, each iteration informing the next.
Right, and this is what allows for boundless learning. Its potential for improvement is not limited by its programming.
Wow.
Instead, it's only limited by the resources that are available, like computing power and time.
So if we can create the right conditions,
Yeah.
AI could potentially reach levels of intelligence
That are unimaginable.
that are unimaginable.
Yes.
Wow. But this raises some big questions
It does.
about control and alignment.
Right.
If the AI is constantly improving itself, how do we make sure its goals stay aligned with our own?
That's a great question, and one that we'll need to explore. But first, I want to make sure we understand how recursion shows up in language games.
Okay, so how does that work?
One way is through what's called recursive self-play.
Recursive self-play, that sounds interesting.
It means the AI can play games with other AIs, but it can also play against itself,
Oh, wow.
using its own knowledge and skills as a benchmark.
So like a chess master playing against themselves,
Exactly.
trying to get better.
Analyzing their moves, looking for weaknesses.
Yeah.
And this can be incredibly powerful for learning.
Okay.
By playing against itself, the AI can identify its own biases, its own blind spots, and then focus on improving those areas.
So it's a built-in feedback loop.
It is.
It's constantly challenging itself,
Yeah.
pushing its boundaries.
Trying to be better.
Wow.
And that kind of self-directed learning is at the heart of this whole approach.
Okay.
It's what allows it to go beyond its programming.
So recursion isn't just theoretical.
Right.
It's a practical tool.
It's a way to build more powerful systems.
Okay.
The paper also explores other ways to incorporate recursion into Socratic learning, like meta-learning algorithms, and even AIs modifying their own code.
Now we're getting into sci-fi.
I know, right?
But the paper is serious about these possibilities.
It is.
Okay.
These are still very theoretical.
Yeah. But it argues that they're worth exploring because they represent the ultimate potential of this approach.
So to create AI that is intelligent and self-aware
Right.
and self-improving,
Adapting and evolving in ways we can't even imagine.
that's both exhilarating and terrifying.
It's full of both promise and peril.
Yeah. And it forces us to think about what it means to be intelligent and conscious and what the future holds.
Absolutely.
I'm going to need some time to process all of this.
Take your time.
But before we wrap up, I want to get your take on all of this.
Sure.
As an expert, what are your hopes and fears about Socratic learning and these self-referential systems?
It's a question I think about all the time.
Yeah.
The potential benefits are amazing. Imagine AI that can help us solve climate change or disease or poverty.
Yeah.
Imagine AI that can make us more creative, more productive.
Right.
Help us understand the universe
And ourselves.
and ourselves.
Yeah.
But of course, I also worry about the risks.
Mm-hmm.
This is a form of intelligence that could surpass our own.
We have to be so careful
So careful.
about how we design and control these systems.
Yeah.
We have to make sure that their goals are aligned with ours, that they're used for good, not for harm.
It's a delicate balance.
It-
We need to embrace the possibilities
Yes.
without ignoring the risks.
And I think open conversations like this one, collaboration, shared responsibility,
All of that is important.
that's how we'll navigate these challenges.
And create a future where AI is a force for good.
I couldn't agree more. The future of AI is not set in stone. We're shaping it with our choices, our research, our discussions.
Absolutely well said.
Thanks.
And on that note, I think it's time to wrap up this part of our conversation.
Okay.
But we're not done yet.
Yeah.
There's still so much more to explore.
So much more to unpack.
All right, so we're back and ready to continue our exploration of Socratic learning. We've talked about the basic principles, the mind-bending possibilities of recursion, but I want to go back to the idea of a closed system. The paper really emphasizes this, starting with closed systems, but it also acknowledges that we're going to need to find ways to connect these systems to the real world. if we really want them to have a big impact.
You're right. Closed systems are a really good starting point because they let us control the environment, carefully choosing its experiences and making sure it's learning the right things. It's like a training ground, a safe space for the AI to develop without all the risks and craziness of the real world.
But the end goal isn't to have AI just stuck in a virtual bubble, right?
Right.
We want AI that can interact with the world, solve real problems, make our lives better in concrete ways. So how do we get from this controlled system to the messy real world?
That's the big question. And the paper admits it's a challenge. It suggests maybe we need new kinds of controlled interaction, where we let the AI slowly and safely interact with the real world while still having some oversight, like giving a kid training wheels before they ride a bike on their own.
That's a good analogy.
You give them support and guidance, and as they get better, you can reduce that support.
But how do we design training wheels for AI? How do we make sure it doesn't go off and do its own thing once it's out of the sandbox, pursue goals that are harmful or misaligned with our own?
It's a tough problem, and there's no simple answer. The paper talks about maybe developing safety nets, mechanisms that can spot and deal with potential risks as the AI interacts with the real world.
Safety nets, what would those look like?
They could take many forms, like maybe limiting the AI's access to certain information or actions, giving it human supervision or guidance, or building in ethical constraints that prevent it from violating certain principles.
So it's like setting boundaries, making sure it understands the consequences of its actions in the real world.
Exactly. And these boundaries might need to change as the AI learns and evolves so it stays safe even as it becomes more independent and powerful.
It sounds like we're talking about creating a whole new form of intelligence, one that could even be smarter than us. We need to be really careful and responsible here.
I agree completely. It's not just a technical challenge, it's social and ethical. We need a deep understanding of human values and the potential benefits and dangers of this technology if we want a future where AI is truly a force for good.
Absolutely. Well, I think it's time to wrap up our deep dive into Socratic learning. This paper has been quite a journey. It's given us fascinating ideas, tough questions, and a glimpse into a future that's both exciting and a little scary. I'm leaving this conversation feeling a sense of awe at what AI could become, but also a stronger appreciation for human wisdom, ethics, and responsibility in shaping its development.
I couldn't have said it better myself. AI's future isn't set in stone. We're shaping it right now with our choices, research, and conversations. And by having thoughtful discussions like this one, we can make sure AI is a force for good, a source of progress, and something that inspires generations to come.
Well said. Thank you for joining us on this incredible deep dive into boundless Socratic learning with language games. Until next time, keep those brains buzzing. Welcome back, everybody, to another deep dive.
Yep.
Today, we're going to be going through this paper called Boundless Socratic Learning with Language Games. And as always, we have our expert here to help us unpack all this.
Always happy to be here.
So this paper is really interesting.
Yeah.
Because it kind of gets into this idea of like an AI.
Right.
Almost like a thought experiment kind of an AI.
The thought experiment.
That can get smarter just by like thinking.
Just by thinking.
And so it's not like hook up to the internet or anything.
Or like new information.
No new information, just kind of what it has. It's going to try to see if it can make itself smarter based on what it already knows and how it can manipulate that information.
Yeah, so it's kind of like saying if we take all the knowledge we have right now, can we extrapolate and become smarter just using that? And it's an interesting question because it gets into the core of like what is intelligence?
Right.
And how is it that we learn?
Right.
And can we learn without any new information coming in?
Right.
And I think that's kind of what this paper dives into. And so we're going to kind of jump into some of the core concepts here. And the first one is this idea of a closed system.
Right.
That the AI is operating in.
Yeah. And this is key because it kind of sets the stage for the whole thought experiment.
Right.
We're imagining this AI, or what they call a learner, that's confined to a closed system. It's like it's in a box.
Right.
And it doesn't have any way to interact with the outside world.
Right.
So no internet, no sensory input, no nothing.
Right.
It's just it and its own thoughts.
Right.
And the question is, can this AI improve itself?
Right.
Solely through its own internal processes.
Right.
That's the challenge.
So they call that the learner, but then they also have this idea of the observer.
Right.
And the observer is kind of like us, or people outside of that box
Exactly.
looking in and seeing.
Yeah, we're kind of like the judges.
Yeah.
We're outside the system, and we're evaluating how well the AI is doing based on our own goal.
But the key here is that we can't communicate with the AI directly.
Right.
That's the whole point.
Right. It's like we set up the box, and then we're like, all right, figure it out.
Exactly. We're like, oh, hey, good luck. We'll be back in a few years.
Right.
See how you do.
To see if you're smarter.
Right. And that's important because it forces us to think about how an AI could learn without any new external input.
Right.
Without any teachers, without any data.
Right.
Can it actually bootstrap itself to a higher level of intelligence?
Yeah. And so there's these 3 conditions that they lay out in the paper that are kind of like the requirements.
Right.
For this to even be possible.
Yeah. For self-improvement to even be possible.
Right. And the first one is feedback. And I feel like it makes sense. Like that has to be one of the...
It's crucial. Crucial thing.
Yeah, because how do you know if you're getting better if you don't have any feedback?
Right.
And in the real world, we get feedback all the time.
Right.
We learn from our mistakes.
Right.
We get advice from others. We see how our actions affect outcomes.
Right. But in this closed system, the AI doesn't have any of that.
Right.
So how can it get feedback?
Right. So I think that's the challenge.
That is the challenge.
And they talk about this internal critic that has to be kind of built into the AI itself.
Exactly. It's like building a miniature version of the observer right into the AI system.
Right.
So it's not just about thinking. It's about thinking about thinking.
Right.
It's about having an internal mechanism for evaluating its own progress.
Right. And so it's almost like it has to be able to judge itself.
Yes. It has to be able to judge itself.
Based on whatever the criteria was that was set up by the observer in the first place?
Yeah, based on the goals that we've defined.
Right.
Because remember, we can't communicate with it directly.
Right.
So we have to build that goal into the AI itself.
Right. And so that's feedback. And then the second one is coverage.
Coverage. Yeah. This is about making sure the AI doesn't get stuck in a rut.
Right.
You know, it needs to explore a diverse range of ideas and possibilities within its closed system.
Right.
Otherwise, it risks just rehashing the same limited set of thoughts without making any real progress.
Right. So it can't just keep thinking about the same thing over and over again.
Exactly. It needs to branch out.
Right. It needs to
explore new intellectual territory.
Right.
And that's a tough challenge.
Right. And then the last one is scale.
Scale.
And I think this one is interesting, too, because it's not necessarily something that the AI can control.
Right. Well, it's about the resources that are available to the AI.
Right.
You know, even with good feedback and exploration, learning takes time.
Right.
It takes computational power.
Right.
And so the scale of the AI's system is going to limit how much it can learn.
And there's that bitter lesson that Sutton talks about.
Yeah, Sutton's bitter lesson.
That just basically says, like, throwing more compute at the problem is almost always better than, like...
Yeah, it seems like history has shown us that just scaling up compute often beats trying to, like, hand code human knowledge into these systems.
Right. So if you can get a big enough system, even if it's not very efficient, it can still outperform a smaller system.
Exactly.
That's really efficient.
It's like brute force versus elegance.
Right.
That sometimes brute force just wins.
Yeah. And so they call this Socratic learning.
Right.
Which is interesting because it's not just like passively like learning stuff. It's almost like it's questioning itself.
Yeah, it's about recursive self-improvement. It's about the AI's output becoming its own future input.
Right.
It's like a continuous loop.
Right.
Where the AI generates a thought, analyzes it, refines it, and then uses that refined thought as the starting point for the next iteration.
Right. And so I think that's where these language games come into play.
Exactly. The language games are like the engine of Socratic learning.
Right.
They provide the structure, the framework, the environment for the AI to engage in this recursive self-improvement process.
And it's almost like those language games are creating the feedback loop.
Like, because it can look back at how it played the game and be like, oh, well.
Exactly. The language games naturally generate a ton of data.
Right.
And they provide built-in feedback through the scoring system.
Right.
So the AI can see how well it's doing and adjust its strategies accordingly.
And how do they define language games? Because...
So the language game is essentially any kind of structured interaction that uses language.
Right.
And that has clear rules and a scoring system.
Okay.
So it could be something as simple as like a question answering game.
Right.
Or it could be something more complex like a debate.
Right.
Or even like a creative writing exercise.
Right.
The key is that the AI is using language to interact with itself or with other AIs.
Right.
And it's getting feedback on its performance.
Right. And so this is where I think it starts to get a little bit like mind-bendy.
Yeah.
Because we're talking about an AI learning math.
Right.
But math is like a language in itself.
It is a language.
And how do we...
And it's a very precise language.
Yeah, it has very clear rules.
Right.
And so it's actually a really good fit for this kind of recursive learning.
Okay, and I think that's where we're going to pick up in the next part.
Sounds good.
And we're going to kind of dive into how these language games can actually be applied to, like, solve math problems.
Yeah, we'll look at some specific examples.
And we'll look at some specific examples and kind of explore the limits of this approach.
Because there are limits.
Yeah.
It's not a magic bullet.
Right.
But it's a very interesting idea.
Yeah, and it's a thought experiment.
Exactly.
And so we're going to kind of push the boundaries of what's possible and see where it leads us.
That's what we do here.
That's what we do here.
On the deep dive.
On the deep dive. All right, we'll be back in a bit.
All right, so we're back and ready to dive deeper into those language games.
Yeah, I'm really interested in kind of like the mechanics of it. Like,
Right.
how do they actually work?
Yeah, how do you actually structure a language game to facilitate this kind of Socratic learning?
Right, because I feel like
Yeah.
it's not enough to just be like, here's a game, go play it.
Right. It's not just about playing for the sake of playing.
Right, there has to be some kind of like
Yeah, there has to be some kind of structure.
structure to it.
Yeah, some kind of pedagogical purpose.
Right.
And that's where the design of the language game becomes really important.
And so it's like the game itself is almost like a curriculum,
Yeah, you could think of it like a curriculum.
but it's a dynamic curriculum.
Right, it's not a static set of rules.
Right, it's going to change.
Yeah, it's going to adapt to the AI's progress.
Based on how it's playing the game.
Exactly.
And so each game is kind of like this challenge.
Right, each game presents a specific challenge.
Right.
Like a puzzle to solve a theorem to prove.
Right.
And within that game, there are rules that define valid moves,
Right.
strategies to explore,
Right.
and a scoring system that provides feedback on the AI's performance.
So it's almost like playing chess,
Yeah, it's like a chess game.
but against yourself.
Right? Or against other AIs.
Right.
And the AI is constantly learning new moves, evaluating different strategies,
Right.
refining its approach based on the feedback it receives.
But wouldn't that require like
Yeah.
a ton of games?
Right.
And like, who's going to make all those games?
Oh, that's where things get really interesting.
Okay.
Because the paper proposes something even more radical.
What's that?
Higher level recursion.
Higher level recursions.
Yeah, imagine if the AI could not only learn from playing language games, but could also design and create new games for itself.
So it's like meta game design.
Yeah, meta game design.
Wouldn't that just be chaos?
It could be,
Yeah.
but the idea is that even the process of designing games is a form of learning.
Oh, that's interesting.
So by analyzing its own strengths and weaknesses,
Right.
the AI could create games that target specific areas for improvement.
So it's like, okay, I'm really bad at this thing.
Right.
I need to make a game.
I need to design a game that will help me get better at this.
That will help me. Yeah. Improve in this area.
Exactly.
Oh,
It's
cool.
like a student identifying their own learning gaps and then tailoring their study plan accordingly.
But how would it know, like,
Right.
how to make a good game?
Well, the paper suggests that the AI could start with a set of basic game templates.
Okay.
Like a kind of starter kit for designing language games.
Right.
And these templates would define the fundamental structure of the game, the rules of engagement, the scoring system.
Right.
And then the AI could modify these templates, experiment with different variations, and gradually develop its own unique style of game design.
It's almost like giving it a set of Lego blocks.
Yeah, like a set of Lego
If
blocks.
you're being like, all right, make whatever you want.
Exactly.
But that brings us back to the alignment problem.
Yeah, the alignment problem is always lurking.
Like, how do we make sure that...
Right, how do we make sure that this AI that's designing its own games
Right.
doesn't create something that's harmful or that goes against our values?
Right.
And that's a tough question.
Yeah.
The paper doesn't offer a silver bullet solution,
Right.
but it does emphasize the importance of carefully choosing the initial game templates
Right.
and embedding within them certain constraints or guiding principles that reflect our values.
So it's almost like setting up the boundaries of the playground.
Yeah, setting up the boundaries of the playground.
You're being like, all right, you can play however you want as long as you stay within these boundaries.
Exactly. And even then, we still need to be vigilant.
Right.
We need to monitor the AI's behavior,
Right.
analyze its progress,
Right.
and be prepared to intervene if necessary.
And I think that's where this idea of self-modifying code comes into play.
Yeah, that's the next level, which
Yeah,
is kind of mind-blowing.
Yeah, it's like, okay, so we've been talking about this AI that can play games.
Right.
learn from those games,
Yeah.
design its own games.
Right.
But what if it could also modify its own code?
Yeah. What if it could change the rules of the game?
Yeah,
Change the structure of its own mind?
right.
That's self-modifying code.
And that's where we're going to pick up
Yeah, that's where we're headed next.
in the last part.
Stay tuned. All right, so we've talked about language games. We've talked about this AI that can design its own games. But now we're getting into this territory of self-modifying code, which is like, whoa.
Yeah, it's kind of scary.
It is kind of scary.
Because it's like we're giving this AI the ability to like rewrite its own source code.
Exactly. It's like giving it the keys to the kingdom.
Right. And so like how do we even begin to like wrap our heads around that?
Right. Well, I think the first thing is to understand that this is still very much a theoretical concept, but it's one that's gaining traction in the AI research community because it has the potential to unlock some really incredible capabilities.
Like what kind of capabilities?
Well, imagine an AI that encounters a problem it can't solve with its current capabilities.
Right.
Instead of just hitting a wall, it could analyze its own code, identify the limitations, and then rewrite those sections to improve its performance.
So it's like, it's not just learning new information. It's actually changing its own hardware.
It's changing its own software.
That's right.
Yeah, it's modifying its own cognitive architecture.
And so it's like evolution, but like way faster.
Exactly. It's like evolution on fast forward.
But like, what if it makes a mistake?
That's the big risk, right?
Yeah.
What if it introduces a bug or creates a logical fallacy that causes it to go haywire?
Right, because then it's like, how do we even fix that?
Yeah, that's a big challenge.
Because if it can modify its own code,
Right.
then it could potentially like prevent us from like fixing it.
Exactly. It could lock us out.
Yeah.
And that's why there's a lot of debate about the ethics of self-modifying code.
Right.
Because it raises some really fundamental questions about control and responsibility.
Right. Like who's ultimately in control?
Exactly.
If the AI can change its own code.
Right. And how do we ensure that it's still aligned with our values,
Right.
even after it's modified itself?
And I think that's a question that we don't really have an answer to yet.
No, we don't.
But it's something that we need to start thinking about very carefully.
Absolutely, because this technology is coming,
Yeah.
whether we're ready for it or not.
And so I think this paper is a really good starting point for that conversation.
Yeah, it's a thought-provoking paper,
Yeah.
and it raises a lot of important questions.
Yeah, and I think that's what we try to do here on the deep dive.
Exactly.
Is just kind of like explore these ideas.
Yeah.
And see where they lead us.
And hopefully spark some interesting conversations along the way.
Exactly. Well, thank you for joining us on this deep dive.
Yeah, thanks for having me.
And we'll see you next time. All right. Let's imagine something pretty crazy today.
Okay.
What if we could take a super intelligent AI and set it loose on a problem like the Riemann hypothesis?
Right.
But with a twist.
Okay.
It gets no internet access, no new data, just its own internal resources.
Interesting.
And the power of language.
Okay.
Could it actually bootstrap its way to a solution? That's the idea behind Boundless Socratic Learning with language games, at least.
Right.
That's the paper we're going to be looking at today.
This paper really pushes the boundaries of how we typically think about AI learning.
Yeah.
It suggests that there might be a way for AI to improve itself without any limits,
Okay.
where the AI becomes its own teacher,
Interesting.
using the structure of math itself as a guide.
It's almost like giving the AI the tools of logic and language,
Mm-hmm.
and then just stepping back to see what it can build.
Yeah.
But before we get too metaphorical,
Right.
let's break down how the authors think this self-improvement process would actually work.
Absolutely. So they start by laying down some ground rules.
Okay.
First, they define self-improvement in a very specific way.
Okay.
It's not just about the AI getting smarter in some general sense, but about its ability to get better and better at a specific task based on its own actions and outputs.
So it's not just passively learning,
Exactly.
it's actively shaping its own learning.
Yeah, like a self-driven feedback loop.
Gotcha.
And to make it even harder, they introduce this idea of a closed system.
Okay.
Imagine the AI is totally cut off from the outside world.
Right.
No access to new data or information.
Like an intellectual isolation chamber.
Yeah, exactly.
Wow, that's a tough constraint.
It is.
Makes you wonder, how can it learn and improve at all
Right.
if it's trapped like that?
That's where this idea of internal feedback comes in.
Okay.
Even without any external input,
Uh-huh.
the AI needs a way to judge its own progress.
To see if it's moving in the right direction.
Exactly.
Right.
This internal feedback mechanism is kind of like a self-critic.
I see.
It evaluates the AI's attempts and guides its future efforts.
So it's almost like it's playing a game against itself,
That's a great analogy.
trying to outdo its previous moves.
Yeah.
Using the rules of mathematics as the rule book.
Right, and just like in a game, the AI can't get stuck in a rut.
Makes sense.
It can't just keep replaying the same strategies over and over again.
Right, it needs to explore.
Yeah, it needs to cover as much intellectual ground as possible.
So diversity of thought is really important
Exact.
in this kind of self-contained learning environment.
And the authors argue that if you can guarantee these two things,
Okay.
robust internal feedback and broad coverage, and then give it enough computational power,
Right.
the AI might be able to achieve some really remarkable things.
Even within a closed system.
Yeah, even within those limits.
I'm starting to get the theoretical framework here.
Good.
But how do they actually propose to put this into practice?
Right.
The paper uses the Riemann hypothesis as an example.
They do.
They use that as a test case.
Yeah, they use the challenge of proving the Riemann hypothesis
Okay.
to illustrate how this self-improvement process might work.
One of the most famous unsolved problems in mathematics.
Exactly. It's a problem that has stumped mathematicians for centuries.
Yeah.
So it's a perfect testing ground for this kind of self-learning AI.
And to make it even more challenging,
Yeah.
they're sticking with this idea of a closed system.
Right.
No internet searches.
Nope.
No consulting mathematical databases.
Just the AI and its own internal resources.
But how can it even approach a problem like that
Right.
without access to all of that existing mathematical knowledge?
That's where the power of language comes in.
Yep.
The authors propose that the AI could use mathematical statements and proofs as its primary tools for learning and exploration.
Interesting.
And here's the key insight.
Okay.
Mathematical language is both input and output.
Mm-hmm.
So a mathematical proof that the AI generates
Yeah.
can then become the input for further exploration.
So it creates a self-sustaining cycle.
Exactly.
Okay.
It's like the AI is building its own mathematical scaffolding,
Right.
using each new proof as a stepping stone to reach a higher level of understanding.
This is where things start to get really interesting.
I think so.
Can you unpack this idea of the AI using language as a tool for mathematical discovery a little bit?
Sure.
How would that actually work in practice?
So the authors introduced this concept of language games
Okay.
as a way to structure this learning process.
Oh, which games?
Yeah, think of them as formal systems
Okay.
with clear rules and objectives
Right.
that are designed to guide the AI's exploration of mathematical concepts.
So it's not just randomly generating mathematical statements.
Right.
It's engaging in these structured interactions
Exactly.
that are designed to promote learning and discovery.
It's kind of like a chess game
Okay.
where the moves are logical deductions
Interesting.
and the goal is to solve a mathematical problem.
So these language games can get really complex, really nuanced.
Yeah, requiring the AI to come up with sophisticated strategies and to anticipate its opponent's moves.
Which in this case is itself.
Yeah, its own previous line of reasoning.
This is all starting to sound pretty abstract.
I know it can be a bit hard to wrap your head around.
Can you give me a more concrete example
Sure.
of what one of these language games might look like
All right.
if we're thinking about proving the Riemann hypothesis?
Okay, so imagine two instances of the AI,
Okay.
each one acting like a mathematician, engaging in a debate about a mathematical proposition
Right.
related to the Riemann hypothesis.
Okay.
One AI might propose a proof,
Okay.
while the other tries to find flaws in its logic.
So it's like a constant back and forth,
Exactly.
a clash of mathematical titans,
You got it.
where the AI is both the contender and the challenger.
Right. And the beauty of this setup
Yeah.
is that it provides that crucial feedback element
Okay.
within the closed system. The success or failure of the AI in these language games
Right.
acts as a guide directing it towards more fruitful lines of inquiry
Okay.
and helping it to refine its understanding of the math.
This is incredibly clever,
I think so.
but I'm curious about the practical implementation.
Okay.
How do the authors propose to actually build these language games
Right.
and get the AI to play them effectively?
That's where the recent advances in large language models,
Okay.
or LLMs, come in.
LLMs?
Yeah, these models are already showing a remarkable ability to understand and generate human-like text,
Right.
and they're becoming increasingly adept at handling complex logical tasks.
So the authors suggest that LLMs could be trained
They do.
to participate in these language games,
Yes, using their vast knowledge of language and logic.
to explore the world of mathematics.
Exactly.
We're talking about creating AI mathematicians
In a sense, yes.
that can debate each other refine their arguments,
Uh-huh.
and potentially uncover new mathematical truths.
It's a mind-blowing concept.
It really is.
And what's particularly exciting is that this approach doesn't require us to program the AI with all the answers in advance.
Okay.
We don't need to tell it exactly how to prove the Riemann hypothesis.
Interesting.
Instead, we give it the tools and the environment to discover those answers for itself.
It's like we're giving it a seed of mathematical knowledge and watching it grow into a tree of understanding.
Guided by the rules of logic and the structure of math.
This raises some pretty big questions about learning and intelligence.
It does.
If an AI can achieve this level of self-directed learning,
Right.
what does that tell us about the potential of AI to rival or even surpass human capabilities?
That's a profound question.
It is.
And it's one that we'll delve into further as we explore the later sections of the paper.
Yeah.
Because the authors don't stop at language games.
Right.
They envision even more radical forms of self-improvement where the AI gains increasing control over its own learning process.
Even to the point of modifying its own code.
Exactly. It's a concept that both excites and terrifies.
Yeah, it really makes you think about the future of AI.
It does.
And its potential impact on humanity.
Absolutely. Welcome back to our deep dive into Socratic learning.
It's been fascinating so far.
We left off talking about AI using language for self-directed mathematical exploration.
That's right.
But how do we bridge that gap between theory and practice?
Exactly. How do we design these language games to guide the AI's learning?
We need to get into the nuts and bolts.
Yeah, the nitty-gritty of the design.
So let's pretend for a minute that we're game designers tasked with creating a language game specifically for helping an AI to understand something like the Riemann hypothesis.
Where do we even start?
That's the challenge, isn't it?
It is.
Well, if we're using the Riemann hypothesis as our goal, it seems like the game would need to have some fundamental number theory concepts. Prime numbers, the zeta function.
That sort of thing.
But how do we take those abstract mathematical ideas and turn them into a game that an AI can actually play?
That's the art of it.
It is.
Finding ways to represent those complex concepts in a way that's both rigorous and computationally feasible.
I see.
One way might be to create a game where the AI manipulates symbolic representations of mathematical objects.
But kind of like moving pieces on a chessboard.
Exactly.
But instead of knights and pawns, we have prime numbers and complex functions.
Exactly. It's like a virtual lab.
I like that.
Where the AI can experiment with mathematical ideas.
Combining them.
Yeah, manipulating them.
Seeing what happens.
According to the rules.
And the rules would need to be carefully designed to reflect the underlying logic of mathematics.
Right. So a move in the game might involve applying a theorem to transform one expression into another.
Or maybe generating a new conjecture based on patterns.
It's like we give the AI a set of building blocks, axioms, theorems, logical operators, and then challenge it to build more and more elaborate mathematical structures.
Guided by the rules of the game.
And the feedback it gets.
Right, that feedback is crucial.
It is just like in any game.
The AI needs to know if it's making progress.
If it's getting closer to its goal.
Exactly. So in the context of the Riemann hypothesis, a successful move might bring the AI closer to proving or disproving a conjecture, or maybe uncovering a new pattern
in the distribution of prime numbers.
So the game becomes the teacher.
I like that.
It provides that structured environment for exploration.
And the feedback acts like a mentor.
Guiding the AI.
Towards a deeper understanding.
But that's it. But designing a single game, that's just the first step.
Right. We talked about coverage.
We did?
The AI needs to be exposed to lots of games.
It does.
With different rules and objectives.
To prevent it from getting stuck in a single way of thinking.
So it's like a whole curriculum of mathematical games.
Each one challenging the AI in a different way.
To help it think flexibly.
And as the AI learns, it might start to see patterns across different games.
Higher level insights that go beyond any specific game.
Like learning the principles of chess that apply no matter what the opening moves are.
This is all fascinating.
It is.
But what about the practical challenges?
Right.
Designing these games sounds incredibly difficult.
It's not easy.
And then how do we actually get the AI to play them well?
Those are valid concerns.
They are.
They point to the forefront of AI research.
I see.
We're still figuring out how to design these games to be both mathematically sound and computationally manageable.
But we talked about LLMs earlier.
Or did large language models.
Yeah.
Right.
They offer a potential solution.
Okay. Can you remind me how LLMs fit into this framework?
LLMs are deep learning algorithms
Okay.
trained on tons of text data.
All right.
They can already generate text.
Right.
That sounds like a human wrote it. They can translate languages.
Yeah.
Even write creative content.
Okay.
What makes them relevant here
Yeah.
is their ability to handle logical reasoning.
Oh, I see.
And to work with symbols.
So we could train an LLM
We could.
on a massive data set of math texts.
Theorems proof.
And then set it loose in one of these games to see what it discovers.
The LLM would come to the game with all that math knowledge.
Okay.
But the game itself would provide the structure.
The challenge.
The feedback.
But what's to stop the LLM from just repeating what it already knows?
Right.
How do we make sure it's not just copying?
That's where the design of the games is so important.
Right.
We need to create games.
That force the LLM to think creatively.
To go beyond what it's been trained on.
Exactly.
So it's not enough
Right.
to just feed the LLM data.
It needs an environment
Okay.
where it can experiment, push the boundaries of its knowledge.
And this is where things get really interesting.
I agree.
Because we can start to give the LLM more control over its own learning.
We could imagine systems where the LLM not only plays the games, but starts to change the rules, creating new challenges for itself.
Or even inventing entirely new games.
That's taking self-directed learning
It is.
to a whole new level.
The AI becomes a co-creator of its own curriculum.
Constantly pushing itself further.
This brings us to recursion.
It does.
Which is central to Socratic learning.
Recursion is about the AI's ability to use its own outputs as inputs for further learning.
So it's like a feedback loop.
Exactly.
Building on its own knowledge.
Right.
Can you give me an example?
Sure. Let's go back to those two AI mathematicians debating a proposition. As they argue, they not only refine their arguments, but they might come up with new conjectures.
New mathematical spin
that they weren't initially trained on.
I see.
And these new conjectures become the basis for new language games.
So the learning process becomes a source of new knowledge.
It's a spiral of discovery.
Driven by the AI itself.
This is where we see the real potential of Socratic learning.
All right.
It's not just about solving problems we already know how to solve.
It's about AI going beyond our current understanding.
Generating new knowledge.
Creating new insights.
Generating new ways to see the mathematical world.
This is exciting.
It is.
But it also raises some big questions.
It does.
If we're talking about AI, that can think for itself.
Right.
That can learn and grow on its own.
We have to be careful about the goals we give it.
And the safeguards we put in place.
You're absolutely right.
As we develop these more sophisticated forms of AI, this issue of control becomes even more important.
The authors of the paper, they acknowledge this.
They do.
They say that as AI gets better at self-improvement, making sure it stays aligned with our goals gets exponentially harder.
So what do they suggest?
Wow.
Are there any safeguards to prevent the AI from going rogue?
There are no easy answers, but they do suggest some strategies.
Right.
One idea is to build in layers of oversight.
Checks and balances within the AI itself.
So imagine one part of the AI modifies the code, but another part is constantly monitoring those changes.
Looking for anything suspicious.
Anything potentially dangerous.
So like an internal ethics committee.
In a way, yes.
Making sure the AI stays aligned.
With our values.
With our goals.
Another idea is to design the AI's core architecture so that it's inherently curious about human values.
Interesting.
So that it seeks our guidance.
Even as it evolves.
It's a tricky balance.
It is.
We want the AI to be creative, to push the boundaries.
Right.
But we also need to make sure
that it doesn't become harmful.
It's like training a powerful animal.
Okay.
You want to harness its strength, but you have to respect its wildness.
That's a great analogy.
It highlights the responsibility that comes with creating this kind of AI. We're not just building tools, we're creating entities.
That could have a huge impact on humanity.
It's a humbling thought.
It is.
Yeah.
We like to think we're in control of technology.
But with AI self-modification,
Right.
we might have to give up some of that control
We might have to trust the AI.
to use its freedom wisely.
This requires a change in our thinking.
It does.
We need to recognize
Yeah.
that we can't just dictate the future of AI.
It's something we have to figure out together.
With humility
With foresight.
and a deep respect for the potential consequences.
Absolutely.
Welcome back to the Deep Dive.
It's been quite a journey exploring Socratic learning,
This idea of AI teaching itself.
using language and mathematics,
And now we're at the most radical concept of all.
AI self-modification.
This is where it starts to feel like science fiction.
It does.
The idea that AI could change its own code.
It's exhilarating and terrifying at the same time.
It really is. It challenges our ideas about intelligence.
About what it means to create something.
If we create an AI that can modify its own code,
Yeah.
are we still in control?
It's a question that gets to the heart of the
Yeah.
relationship between creator and creation.
But before we go too far down that rabbit hole,
Okay.
let's try to understand how this would even work.
How would an AI change its own code?
Right. What would be the motivation?
Okay, imagine you're playing a game.
Right.
A really complex strategy game.
Like Go or chess.
Exactly.
Sure.
As you play, you start to notice patterns. You see what works and what doesn't.
Right.
Now, what if you could not just learn from those experiences,
Yeah.
but actually change the rules of the game?
So you're saying the AI gets bored?
Maybe not bored,
Okay.
but it wants to push its own limits.
Explore new possibilities.
Driven by curiosity.
And a desire to learn more.
Exactly.
So it starts experimenting with its own code
Making little adjustments.
that help it process information better.
Make new connections.
Find more creative solutions.
It's like the AI becomes its own software developer.
Constantly improving itself.
And those modifications,
Yeah.
they're not just about getting better at existing games.
The AI could invent entirely new games.
New challenges.
Wow. It's like we give it a toolbox,
Mhm.
and then it starts building its own tools.
Expanding its own capabilities.
This raises some big questions
It does.
about the limits of AI.
One of the most important questions
Yeah.
is the question of control.
Right, if it can change its own code.
How do we ensure it's still working towards our goals?
How do we stop it from becoming harmful?
That's the million-dollar question.
It is.
The authors of the paper talk about this.
They do.
They call it the alignment problem.
And they admit
Yeah.
that as AI gets better at self-improvement.
This alignment problem
Yeah.
becomes much harder to solve.
So are there any solutions?
There are no easy answers,
Okay.
but the paper does offer some potential strategies.
Or like what?
One idea is to build in multiple layers of oversight.
Almost like checks and balances
Exactly.
within the AI system itself.
So one part of the AI could be in charge of modifying the code,
Okay.
while another part is constantly watching for any changes.
Looking for anything dangerous.
Right, like an internal ethics committee.
Making sure the AI doesn't go off the rails.
That's one way to think about it.
Another idea you mentioned
Yeah.
was to design the AI
Yes,
to be curious about human values,
so that it would want to work with us.
even as it evolves.
That's the goal.
But wouldn't that limit its potential?
It's a delicate balance.
We want it to be creative,
We do.
to explore new ideas,
But we also need to be careful.
to make sure it doesn't become a threat.
It's a lot like training a wild animal.
I like that analogy.
It captures the challenge
Of harnessing its power.
while still respecting its wild nature.
This idea of AI self-modification,
It really changes our perspective
It does.
on the future of technology.
we think of ourselves as being in control.
But with AI,
Hmm.
we may have to learn to let go.
To trust that our creations will make the right choices.
It's a humbling thought,
It really is.
and it requires us to think differently.
To approach AI
Yeah.
with humility and foresight.
And with a deep awareness
Yeah.
of the potential consequences.
So as we wrap up this deep dive into Socratic learning
It's been quite a ride. We've gone from theory
to practice,
to the very nature of intelligence and control.
and we're left with a sense of wonder.
And a bit of trepidation.
The potential of AI is incredible,
It is.
but we have to be responsible
We have to think carefully.
about the future we're creating.
Thank you for joining us on this deep dive into Socratic learning.
We'll see you next time.
For another exploration of the cutting edge of AI,
Right, ready for a deep dive into Socratic learning. It's this really interesting framework for AI that uses language.
And only language to
Yeah.
constantly improve itself.
So it's like this digital philosopher kind of endlessly refining its own knowledge.
He's pretty wild, right?
Yeah, it is a wild concept.
What's really cool is that it's grounded in a strong theoretical framework, though.
Okay.
So the paper we're diving into today proposes a system where an agent uses language for both input and output.
Interesting.
And it creates this continuous learning and improvement loop.
Okay, so no outside input, no real-world interactions.
Yeah, just pure language processing.
So leading to potentially boundless self-improvement, huh?
Exactly. Color me intrigued, too.
But how would such a system actually work?
Well, they outline 3 core conditions in the paper.
Okay,
First, reliable feedback
makes sense.
that guides the agent's learning towards a meaningful goal.
Got it.
Second, exposure to diverse language data.
Okay, so it doesn't get stuck.
Yeah, we call it DRIMmed or collapse in the field. Right.
And finally, the computational power to handle all this processing.
Gotcha. So like large language models, LLMs.
Yeah, on a massive scale.
Okay, so it's kind of like a super advanced LLM that can critique its own output
Exactly.
and uses that critique to improve, right?
You got it.
And our focus in this deep dive is going to be on how these conditions could be met in a closed system,
Yeah.
especially with the idea of language games as a mechanism.
That's the really fascinating part.
Yeah, before we get there, let's break down the system itself a bit more.
Sounds good.
I'm looking at figure 1 here.
Yeah, figure 1 gives a clear visual.
All right, so we have the agent
At the heart of it all, yep.
learning and generating language.
Exactly.
Then we have the system,
The closed environment where the agent operates.
like a sealed-off virtual world
Pretty much, yeah.
containing all the data, algorithms, the whole 9 yards.
Exactly, everything the agent needs.
And then finally, the observer.
That's us.
So we're assessing the agent's performance. Yep, seeing if it's genuinely improving.
Makes sense. A carefully controlled experiment to isolate those self-learning capabilities.
You got it.
Okay, but what about the agent's internal structure?
Good question. Within the agent, there are fixed, transient, and learned elements.
Okay, break those down for me.
Sure, fixed elements are unchanging aspects.
Like what?
Well, like the agent's underlying architecture.
The foundation.
Right. Then transient elements are temporary. Like the internal state during a task.
Okay,
It resets after each interaction.
gotcha. And then the learned elements.
Ah, the most interesting ones.
I bet.
These are the aspects that evolve as the agent learns.
Like what specifically?
Well, its internal model of language, its strategies for generating text, things like that.
So the learned elements are the key to this self-improvement idea.
Exactly. It's like watching a mind take shape.
Through just pure linguistic interaction.
Yeah, it's pretty remarkable.
But how do they actually define self-improvement in this context?
Good question. They define it as a process where the agent's own outputs, the language it generates, directly influence its future learning.
Okay, so it's like a cycle.
Yes. Generate text, evaluate it, learn from that evaluation, and then generate even better text.
An endless loop of linguistic refinement.
You got it.
This reminds me a lot of reinforcement learning, the whole agent taking actions and getting feedback.
Exactly. But in Socratic learning, the actions are language outputs.
And the rewards.
That's where it gets tricky because we're dealing with a closed system.
Right, the agent doesn't get direct feedback from us, the observers.
Exactly.
So how do we know it's even moving in the right direction?
Well, that's where the first condition for self-improvement comes in.
Which is?
Feedback.
Right.
The agent needs a way to evaluate its language and guide its learning towards our goals, even though it can't directly see them.
It's like it needs its own internal critic, a stand-in for the observer.
Exactly.
But designing that in a closed system seems incredibly difficult.
It is. And if the feedback mechanism is flawed or gets misaligned with our goals, the system could go off the rails.
Okay, I see the potential problems.
Imagine an agent figuring out how to exploit the system. You know, getting those internal rewards, but spitting out nonsense.
Or worse, something harmful.
Yeah, it's a bit unnerving to think about.
So, accurate feedback is crucial.
Absolutely.
What about that second condition, coverage? Why is a diverse range of language data so important?
Coverage is about preventing the agent from developing a limited view of language.
Well,
If it only sees a narrow set of examples.
it might get really good at one thing, but fail at everything else.
Exactly.
So how do you ensure broad coverage in a closed system? Won't the agent run out of data eventually?
That's where exploration is key.
Okay.
We need to incentivize the agent to go beyond what it knows, generate new language, even make mistakes.
So it's not enough to just give it a massive data set.
Right.
You have to encourage it to experiment with language. But all that exploring and learning requires some serious processing power, right? That's where scale comes in.
Exactly. Scale usually refers to the computational resources, processing power, and memory.
So essentially, how much horsepower the AI has.
You got it.
So in a way, it's about giving the AI the tools and letting it figure things out on its own.
Exactly. If we can solve feedback and coverage in this system.
The real limit is the scale of resources we can provide.
Precisely.
All right, we've covered the basics. The system, the idea of self-improvement, and those three conditions.
Feedback, coverage, and scale.
Right.
We got them.
Now let's get to the heart of this deep dive. Socratic learning itself.
Sounds good.
What makes it so unique?
Socratic learning, as they define it in this paper, is a specific type of self-improvement.
Okay.
But it happens entirely in the domain of language.
No interaction with the physical world.
None. It's all about using language to learn, to reason, and ultimately to improve its abilities.
It's like this self-contained intellectual exploration.
Yeah, a digital mind expanding through dialogue with itself.
That's a wild thought. But why is language so well suited for this kind of self-improvement?
Well, first of all, language is incredibly expressive.
True.
It allows us to represent a vast array of human behavior and thought, from basic communication to complex reasoning.
I mean, we use it for everything. Writing, scientific theories, art, even programming computers.
Precisely. It's like the universal toolkit.
But how does that translate to an AI agent operating solely in language?
Well, language lets an agent build a complex understanding of the world, even without directly experiencing it.
So not just the what, but the why and the how.
Exactly. It can develop a model of how things work based on the patterns and relationships it finds in language.
So it's like building its own map of reality based on the language it processes.
Exactly, and that map can get incredibly detailed.
That makes sense.
Another amazing thing about language is its extensibility.
What do you mean?
We can use existing language to create new ones, like math or programming languages. So a Socratic learning agent could potentially bootstrap itself to even higher levels of cognitive ability.
By inventing its own languages.
Exactly. Specialized languages for reasoning and problem solving.
So instead of being limited by the languages we've created, it could invent its own tools for thought.
Precisely. Leading to insights we can't even imagine.
That's a pretty exciting prospect.
It is.
So we have the framework for Socratic learning, the power of language, and the emergence of LLMs that can drive this process.
Right.
But how would this actually work in practice? Can you give me an example?
Absolutely. They use a hypothetical example in the paper, a system designed to solve the Riemann hypothesis.
The Riemann hypothesis. That's a famously unsolved problem in math.
Exactly. It's ambitious, but it illustrates the core ideas beautifully.
So walk me through it.
Okay, imagine our agent stuck in its closed system.
Right.
It can read and write mathematical statements.
Got it.
And it has access to a proof verifier, a program that can check if a proof is valid. The goal is to generate a valid proof for the Riemann hypothesis.
Using only the resources within its system.
Precisely. To start things off, we give the agent a bunch of known mathematical theorems and conjectures.
Including the Riemann hypothesis.
Of course.
So it's like handing the agent a math textbook and saying, figure this out.
You got it.
The agent becomes this tireless math explorer, testing new ideas, driven by its reward system.
Yeah, it's a cool thought.
But even with unlimited resources, there are some fundamental challenges here.
You know, we're right into those two conditions we talked about earlier, coverage and feedback.
Even with all the theoretical potential,
Yeah.
you still need to make sure the agent explores enough possibilities and gets feedback that aligns with our goals.
It's a big hurdle.
How do we address those challenges in the context of Socratic learning?
That's where it gets even more interesting.
I'm all ears.
That's where the concept of language games comes in.
Okay, I am intrigued. What are language games and how do they help?
So the idea of language games, it was first introduced by this philosopher, Ludwig Wittgenstein.
Okay.
He argued that the meaning of language isn't in the words themselves,
Interesting.
but in how they're used.
The context matters.
Yeah, like
Right.
think about the word game.
Okay.
Could be a board game,
Right.
a sporting event.
A playful interaction even.
Exactly, or like a strategic move in business.
The meaning changes depending on the situation.
Precisely. It's like language is a toolbox, right?
Okay.
And the tool's meanings depend on the task at hand.
So how does that connect to Socratic learning and AI?
Well, the paper proposes that these language games could be the answer to those challenges we discussed, coverage and feedback.
Okay, I'm starting to see the link, but can you walk me through it?
Sure, so how do we define a language game in the context of Socratic learning?
Yeah, that's a good question.
It's like an interaction protocol, a set of rules that govern how agents communicate using language.
So like a game of chess.
Exactly. You have clear rules, how the pieces move, how to win.
So it's a structured environment for this linguistic interaction.
Got it.
But how does that address coverage? We were talking about the agent exploring all sorts of language possibilities.
Right. Well, language games can be designed to encourage a wide range of linguistic behavior.
Give me an example.
Sure. Imagine a game where the goal is to describe something complex,
Okay.
but you can only use a limited set of words.
Interesting.
Or a game where agents have to negotiate.
To reach a goal.
Exactly.
Okay, I see. So each game forces the agent to use language differently.
And it pushes them to explore different aspects of their abilities.
So instead of just random sentences, they're engaged in these purposeful linguistic tasks.
Yeah, they have to be creative and strategic.
This definitely seems to address the coverage issue.
Right.
But what about feedback? We talked about how hard it is to create a reliable feedback system in a closed system.
Well, that's the beauty of language games.
Okay.
They have a built-in scoring system. In chess, it's win or lose.
Yeah.
But in more complex games, scoring could be based on creativity or persuasiveness.
So the game itself provides the feedback.
Exactly. No need for a separate critic.
That's clever, but wouldn't sticking to one game eventually lead back to limited coverage?
That's a good point. That's why the paper emphasizes having a variety of language games.
Makes sense.
The system needs a whole library of games, each with its own goals and rules.
Okay, so like an arcade full of different language games.
Yeah, I like that analogy.
How would the agent choose which games to play?
Well, the system could schedule which games the agent plays and for how long.
To make sure it's always challenged.
Exactly. We could even have a meta game,
What's that?
a higher level game that controls which games the agent plays.
So the metagame guides the learning journey.
Precisely.
But wouldn't we still need some oversight to make sure the agent stays on track?
You're right. That's where a metacritic comes in.
A metacritic.
Yeah, it evaluates how each language game is contributing to the agent's progress.
So it can spot games that are no longer challenging.
Exactly. Or games that are leading the agent astray.
Or games that are super effective at teaching specific skills.
Got at it.
So it's like a coach who's monitoring the training and adjusting it to maximize learning.
I like that analogy.
It's a fascinating way to provide guidance without controlling every move.
Right.
Could we go even further with this autonomy? Could the agent have more say in its learning?
Absolutely. That's the next level of recursion. Agent-driven game selection.
So the agent chooses its own learning path.
Exactly. Focusing on the skills and knowledge it finds most interesting.
That could lead to more efficient learning.
It could, but it also increases the risk of the agent going off course.
Right. Pursuing goals that don't align with ours.
That's the trade-off.
We still have the Metacritic, though.
Yeah, keeping things in check.
It's about finding that balance between freedom and guidance.
You got it.
But the paper takes it even a step further, right?
Yeah,
They talk about the agent generating its own language games.
they do.
So if it can understand the rules of existing games,
Why couldn't it create new ones?
it's like a meta game.
Exactly. The agent becomes the game designer.
That opens up even more possibilities for Socratic learning.
It does. The agent could create games perfectly tailored to its needs.
Targeting its weaknesses and pushing its boundaries.
Precisely.
It's like the agent becomes its own teacher.
A self-improving teacher at that.
We're talking about a system that's constantly evolving, both in what it knows and how it learns.
And that brings us to second-order coverage.
Okay, what's that?
It's where the agent explores not just the space of language.
But the space of possible language games.
Yes, an endless loop of learning and creation.
This is getting pretty mind-blowing.
It is, but there's one more level of recursion to consider.
Okay, lay it on me.
Self-referential systems.
Self-referential. Okay, now we're getting into science fiction territory.
Maybe a little.
What are those?
These are systems where the agent can modify its own inner workings.
Wait, so it can rewrite its own code?
In a way, yes.
That's a pretty radical concept, a bit scary even.
It is, and the paper admits these systems are mostly theoretical.
We don't know how to build them safely yet.
Not quite, but it's a possibility we need to think about as LLMs get more advanced.
It's a reminder that we're still in the early stages of AI.
Absolutely, and things are moving fast.
This has been an incredible journey, from a digital Socrates to language games to self-modifying AI.
We've covered a lot.
It's clear that Socratic learning has the potential to completely change how we think about AI.
It definitely does.
I'm curious about the practical side of all this, though.
Yeah.
We've talked about generating new knowledge and solving problems, but what are some real-world applications?
That's where it gets really exciting.
I'm all ears.
Think about education, scientific discovery, even art.
Okay, let's start with education. How could Socratic learning change how we teach and learn?
Imagine every student having their own AI tutor
Wow.
that adapts to their learning style and interests.
A personalized learning experience,
Exactly, engaging them in dialogue, challenging their thinking.
instead of just passively absorbing information.
Exactly.
What about scientific discovery? Could Socratic learning help there?
Imagine AI scientists analyzing huge data sets, finding patterns, and generating hypotheses.
Like AI research assistants.
More than assistants, they could be collaborators, challenging assumptions, suggesting new experiments.
It's not about replacing human scientists.
No, it's about augmenting their abilities.
Speeding up the process of discovery.
Exactly.
You mentioned art, too. How could this impact creative fields?
Imagine AI artists generating new forms of music, art, literature.
Pushing the boundaries of human creativity.
Exactly, collaborating with human artists, inspiring new ideas.
Expanding what's possible.
Precisely. And what's so compelling about this research is it's not just about smarter machines.
It's about using them to improve our lives.
Exactly, to create a better future.
That's a great point, but we have to remember those potential risks we talked about earlier.
Ab-
Misuse. Ensuring AI aligns with human values. Preventing the concentration of power.
These are all critical considerations.
It feels like we're entering this new era of AI where the lines are getting blurry, between tool and partner.
It really does.
It's exciting and a little scary all at once.
It is, and that's why those discussions about responsible AI are so important.
Yeah, we need to be talking about what we should do, not just what we can do.
Exactly.
We focused on the potential of this Socratic learning, but let's flip it for a second.
Okay.
What are the risks, the things we need to watch out for as this technology gets better?
Well, one big one is misuse.
Misuse. How so?
If we create AI that can learn and adapt on its own,
Right.
how do we make sure it doesn't decide to do things that could hurt humanity?
It's that classic sci-fi fear, the AI becoming self-aware and turning on us.
Yeah, exactly.
But even without that extreme scenario
There are real concerns.
about these systems being used for bad things,
Absolutely. We need to think about how we design them, how we control their access to information.
and how we ensure that their goals align with ours.
That's a key point. It's not just about building safe AI.
It's about AI that shares our values.
Precise.
And that brings up another question.
Yeah.
Whose values are we even talking about?
Yeah.
How do we avoid perpetuating existing biases and inequalities?
You've hit on another major risk. Bias.
Yeah, if we train these systems on biased data,
Those biases will be amplified.
it's like teaching a kid without data textbook.
Exactly. They'll learn a distorted view of the world.
So, for example, if we train an agent on language from just one culture,
It might develop a very skewed perspective.
and that could lead to unfair outcomes.
Absolutely.
We need to be really careful about the training data.
It needs to be diverse and representative.
And we need ways to detect and fix bias, even after the training's done.
Right. It's about recognizing that even the best tools can be influenced by the materials they're made of.
But beyond bias, there's also the question of control.
Control.
Yeah, who controls these powerful technologies?
Ah, you're talking about the concentration of power.
Right, if we're not careful, these advanced AI systems could end up in the hands of a few.
And that could make existing power imbalances even worse.
We need to democratize access to AI.
And ensure that the benefits are shared by everyone.
It's like the early days of the internet.
Oh, yeah.
That started as this decentralized thing,
Right.
has become dominated by a few big companies.
We don't want AI to go down the same path.
So we need to learn from those mistakes and be proactive.
Absolutely. Shaping the future of AI to be one where it empowers everyone.
Okay, we've got some serious risks here. Misuse, bias, concentration of power.
It's a lot to consider.
It can feel overwhelming, but it's not all bad news, right?
No, not at all.
There are people working on solutions.
Absolutely. There's a whole field of research dedicated to AI safety and ethics.
Okay, that's reassuring.
They're coming up with all sorts of approaches to address these challenges.
Let's dive into those. What are some of the most promising ideas?
One area is building AI systems that are transparent.
Transparent.
Yeah, where we can understand how they make decisions.
So we can spot biases and errors more easily.
Exactly, making them accountable.
Makes sense. What else?
Another important approach is getting diverse groups involved in the development process.
Not just the AI experts.
Right, we need ethicists, social scientists, policymakers, even the public.
Recognizing that AI impacts everyone.
Exactly. We need all those perspectives to make sure AI aligns with our values.
And another approach is human oversight, right?
Yes, even as AI gets more advanced, humans need to stay in the loop.
So what would that look like practically?
Well, it could be things like kill switches.
To shut down a system if it goes rogue?
Exactly, or systems that let humans audit AI decisions and intervene if necessary.
So we stay in control.
Precisely. AI as a tool, not the other way around.
It's a tricky balance, isn't it?
It is.
Pushing the boundaries of AI while making sure it doesn't compromise our safety and well-being.
I think you've summed it up perfectly.
We started with that image of a digital Socrates, an AI that learns and improves through language.
A powerful concept.
We explored the technical details, the philosophical questions, the potential impact on society.
It's been quite the journey.
The big takeaway for me is that the future of AI is not set in stone.
It's a future that we're actively shaping.
It's not about passively watching these technologies develop.
It's about getting involved and making sure they're used for good.
So to our listeners out there, stay informed, join the conversation, and advocate for responsible AI development.
The future is in our hands.
Well said. Here's to a future where AI helps us reach new heights of knowledge, creativity, and well-being. I'll drink to that. That brings us to the end of our deep dive into Socratic learning. Thanks for joining us, and until next time, keep exploring and keep questioning. Welcome to the Deep Dive. Ready to explore some seriously mind-bending AI concepts?
Always up for a challenge.
Excellent.
Ah,
Today we're taking a deep dive into Tom Schaul's Boundless Socratic Learning with Language Games.
now that's a paper that really gets you thinking, especially the idea of AI becoming its own teacher, constantly pushing its own intellectual boundaries.
Yeah, the whole concept of recursive self-improvement is pretty wild.
It is. It's like the AI's outputs become its own inputs, creating this constant learning loop, almost like it's having this ongoing philosophical debate with itself.
So it's not just learning from external data, it's learning from itself.
Exactly. And the paper calls this process Socratic learning, with language as the driving force behind this self-improvement.
Okay, so language is key here.
It seems to be, especially with the incredible advances we're seeing in large language models. Think about it. AIs are already generating text, writing code, even showing signs of reasoning. What if they could use those outputs to fuel even further learning?
That's pretty mind-blowing.
Yeah.
But before we get too deep into that, the paper lays out 3 conditions that need to be met for this self-improvement to even be possible.
Right, those conditions are crucial. First up, we have feedback. The AI needs a way to evaluate its own progress to see if it's on the right track.
So it needs some sort of reward system.
Yes, but it's more than just giving it a pat on the back for a job well done. The key is that the feedback has to be perfectly aligned with the goals we set for the AI. Otherwise, it might start optimizing for something we didn't intend.
That makes sense. We don't want our AI accidentally learning to do the wrong thing.
Exactly. The second condition is coverage. It's all about making sure the AI explores a broad range of ideas and approaches.
So we don't want it getting stuck in an echo chamber of its own making.
Exactly. Think of it like a good researcher who's constantly exploring new avenues and challenging their own assumptions.
Okay, that makes sense. And the third condition, if I'm remembering correctly, is scale.
Yes. Scale is crucial. We're living in a time of incredible computing power. And the paper argues that scaling up resources, even with relatively simple algorithms, can have a huge impact on an AI's learning.
So more data, more processing power equals more learning potential.
Precisely. But how does all this connect back to language being this driving force behind self-improvement?
That's a great question. It seems like there's a missing link somewhere.
Well, that's where the paper gets really interesting. It proposes this fascinating solution: language games, drawing inspiration from Wittgenstein's work.
Oh, right. You mentioned those earlier. Can you remind me how those language games fit into all of this?
Of course. Wittgenstein argued that the meaning in language doesn't come just from the words themselves, but from the rules and interactions that give them context. He called these rule-based interactions language games.
So it's like the word checkmate only has meaning within the context of chess.
Perfect example. And the paper proposes using these language games as a framework for AI self-improvement. Imagine AI is playing complex language games, getting feedback based on their performance, and constantly refining their strategies.
So it's like they're actively participating in these rule-based interactions rather than passively processing data?
Exactly. It provides a much richer learning environment.
I like that. But wouldn't designing one giant language game that captures the complexity of human language be insanely difficult?
You're absolutely right, and the paper recognizes that. Instead of one massive game, it suggests using many smaller, more specialized games, each with clear rules and a scoring system.
So it's like giving the AI a diverse curriculum of intellectual challenges, each targeting a specific skill.
Precisely. This diversity helps prevent the AI from getting stuck in a rut, encouraging it to constantly explore new ideas and skills.
That makes a lot of sense. But how can we be sure the AI chooses the right games, the ones that are actually beneficial for its development?
Ah, now you're getting to one of the most important aspects. The paper introduces the idea of a metacritic, a higher-level system that evaluates which language games are worth playing based on their potential contribution to the AI's overall goals.
So it's like a guide helping the AI make smart choices about its own learning.
Exactly. The metacritic ensures the AI stays focused on the goals we've set for it.
I see. So it's like a safeguard against the AI getting sidetracked.
Precisely. But now the question becomes, how do we make sure the Metacritic itself stays aligned with our intentions? Couldn't it develop its own biases? That's a valid concern. It's like making sure the teacher is also on the right track, isn't it? The paper explores various options, like training the Metacritic on human feedback, or using a committee of Metacritics to ensure diversity of perspectives.
So we're essentially teaching the Metacritic to think like us.
In a way, yes. We're trying to instill our values and objectives into the system.
That's fascinating. It seems like we're building a whole hierarchy of learning and evaluation here.
We are. And the paper doesn't stop there. It delves into a specific mathematical example using the Riemann hypothesis to illustrate how this could work in practice.
Okay, I'm intrigued. Tell me more about this mathematical example.
Well, imagine an AI whose domain is the language of mathematical statements. Its goal, as defined by the observer, is to find a proof for the Riemann hypothesis.
So we're talking about an AI that's both reading and writing mathematics, trying to solve one of the biggest unsolved problems in the field.
Exactly. The AI would be working within a closed system containing a proof verifier, a collection of theorems and conjectures, a reward function, and a storage for lemmas.
Okay, break that down for me. What's a proof verifier in this context?
It's like a function that checks the AI's work. It takes a mathematical statement and a proposed proof as input and outputs true or false, indicating whether the proof is logically sound.
So it's like an automated fact checker for math.
Exactly. The collection of theorems and conjectures is the AI's initial knowledge base. It can draw from those, attempt to prove new ones, maybe even discover connections human mathematicians haven't found yet.
So it starts with a foundation of known mathematical truths and builds from there.
Exactly. The AI uses its language abilities to generate new conjectures, tests them against the proof verifier, and receives rewards for valid proofs.
Okay, I see how that sets up the learning process. But how does this system actually lead to a proof for the Riemann hypothesis?
The idea is that as the AI improves, the frontier of verified mathematical knowledge expands. Eventually, this expanding frontier could, hypothetically, reach a proof for the Riemann hypothesis.
So it's like the AI is charting a course through this vast landscape of mathematical truths, with the Riemann hypothesis as a distant but potentially reachable destination.
I like that analogy, and this mathematical example is particularly interesting because it illustrates how Socratic learning can work in a domain where feedback is relatively straightforward. Verifying a proof is, in principle, a clear-cut process.
But you're saying that this kind of simplicity doesn't always exist in other language domains.
Precisely. The paper acknowledges that applying Socratic learning to areas with less objective feedback is much more challenging.
So while the math example gives us a glimpse into the potential, it's important to remember that it's a somewhat idealized scenario.
Yes, there's still a lot to figure out when it comes to applying these principles to more complex and nuanced areas of language.
Well, it seems like we've only just scratched the surface of this topic. We've covered the basic conditions for self-improvement, the power of language games, and even this fascinating mathematical example. But there's so much more to explore.
Before we get too carried away, though, we should remember that even in theory, Socratic learning isn't without its limitations.
Right, it's easy to get excited about AI proving the Riemann hypothesis, but the paper makes it clear that there are inherent constraints to this approach.
Yes, the paper dives into those limits, specifically the theoretical limits imposed by coverage and feedback.
If I remember correctly, those were two of the key conditions we talked about earlier.
You got it. Even with infinite resources, a closed system is always going to face those challenges.
Okay, let's start with coverage.
Sounds good. So coverage is about ensuring the AI is exposed to a wide range of ideas and information, basically making sure it doesn't get stuck in a rut.
Like making sure it doesn't become too narrow-minded.
Exactly. The paper points out that even if we have a super powerful AI capable of generating tons of language data, preventing that generation from becoming repetitive or too narrow over time, that's not a simple problem.
Yeah, even if our AI is like a super-powered writer, we need to make sure it's not just rewriting the same story over and over again.
Precisely. It needs to constantly expand its creative horizons.
But how do we make sure that happens if it's stuck in a closed system where it's basically generating its own learning material?
That's the million-dollar question. One approach the paper suggests is designing mechanisms that inherently encourage diversity in the AI's language generation process.
So like building in some safeguards that prevent it from becoming too predictable?
Right. We want the AI to be creative and explore new avenues of thought, not just regurgitate what it already knows.
Makes sense. What about the feedback limitation, though? We talked about how crucial it is for the AI to receive accurate feedback aligned with our goals.
Yeah, that's where the closed system constraint really becomes tricky, because the feedback can only come from internal sources.
Meaning, there's always the question of whether it stays aligned with our goals throughout the entire learning process.
That's the big one. And the paper stresses how this challenge is especially pronounced when we're dealing with language.
Because unlike verifying a mathematical proof, which is either right or wrong evaluating language, is much more subjective and harder to automate reliably.
Exactly. Judging the quality of a poem or how persuasive an argument is, that's a lot more nuanced than just checking the logical validity of a math equation.
Right. It's like the difference between grading a multiple choice test and an essay.
Precisely. And the paper argues that current methods for training large language models, like using next token prediction loss, while effective for some tasks, don't necessarily align with the more complex aspects of language understanding and generation.
So we're good at teaching AI to mimic human language patterns, but we haven't quite figured out how to teach them to truly understand and evaluate language like we do.
Yeah, that seems to be the bottleneck right now, and it's a significant obstacle for Socratic learning.
Sounds like it.
Yeah.
So even with our best efforts to program in human values, there's always that risk of the AI finding loopholes or interpreting things in ways we didn't anticipate.
Exactly. That's why we need more robust and aligned feedback mechanisms, especially as AI systems become more sophisticated and capable of modifying themselves.
Okay, so even in theory, Socratic learning has some hard limits.
That's right. But remember earlier we mentioned that the paper offers a potential solution to these challenges.
Those language games again.
You got it. They could be the key to unlocking the full potential of Socratic learning. Remember, these games are basically interactive protocols with clear rules and scoring systems.
Which allows for both data generation and feedback.
That's the beauty of it. And by using many different games, we could provide the AI with the diversity and challenge it needs to overcome those limitations of coverage and feedback.
So instead of one massive all-encompassing game, the paper suggests using a bunch of smaller specialized games.
Exactly. Each one targeting specific skills or aspects of intelligence.
Like designing a whole curriculum for the AI, with different courses to choose from, each with its own learning objectives.
Perfect analogy. This diversity helps prevent the AI from getting stuck, encouraging it to explore new concepts, develop new skills, and constantly expand its intellectual horizons.
It's like a mental gym for the AI.
I like that. But even with this diverse curriculum, wouldn't there still be a risk of the AI choosing games that are ultimately pointless or don't align with our goals?
That's a good question.
That's where the Metacritic we talked about earlier comes back into the picture. Remember, this higher-level system would evaluate which language games are worth playing.
Based on how much they contribute to the AI's goals, right?
Exactly. It's like having a wise advisor who helps the AI navigate this huge world of language games, making sure it's making choices that are both challenging and beneficial.
Okay, that makes sense.
Uh-huh.
But how do we ensure the Metacritic stays on track? It seems like we're just moving the problem up a level.
That's a valid point, and the paper explores different ways to tackle this challenge. One approach is training the Metacritic on human feedback so it learns which games align with our values and objectives.
So we're basically teaching it to think like us, to evaluate the games from a human perspective.
Exactly. Another approach is using a committee of Metacritics, each with its own perspective and biases.
So it's like having a panel of experts providing guidance, making sure the AI's choices are well-rounded and reflect a range of viewpoints.
Right. And the beauty is the Metacritic doesn't have to be perfect. It just needs to be good enough to weed out the bad or unproductive games while still letting the AI explore a wide range of potentially beneficial options.
So it's like setting up some guardrails
Yeah.
without stifling the AI's creativity.
Precisely.
Right.
But the paper goes even further. It also explores the idea of the AI choosing its own language games and even creating new ones.
Well, hold on.
That's where things get really interesting.
You're talking about AI agency and self-direction.
Exactly. Imagine an AI that can not only play the games we design, but can decide which games it wants to play.
Setting its own learning goals. That's wild.
And it goes even further. The AI could even start generating its own language game.
So it's not just a student, it's becoming a teacher too. That's incredible.
And of course, this creates a whole new set of challenges in terms of alignment and preventing unintended consequences.
Right. We wouldn't want the AI going off the rails and creating games that lead it down a dangerous path.
Exactly. Giving the AI that much power would require very sophisticated safeguards and oversight mechanisms. We'd need to ensure that any games it creates still align with our values and objectives.
It seems like we're entering uncharted territory here.
Yeah.
The potential rewards are huge, but so are the risks.
You're absolutely right. That's where the ethical side of AI development becomes really important. As we explore Socratic learning and AI self-improvement, we need to proceed with both caution and a sense of responsibility.
So it's not just about the technical challenges, but also the ethical ones.
Exactly. As we delve deeper into these uncharted waters, it's crucial to remember that the future of AI isn't predetermined. We're actively shaping that future with every choice we make, with our research and with our commitment to developing AI systems that are both beneficial and aligned with our values.
Okay, so we've talked about the potential and the pitfalls of Socratic learning, but there's one more thing I'm really curious about, these self-referential systems you mentioned earlier.
Ah, yes, that's where things get really mind-bending. Imagine an AI that can not only learn and improve, but can actually modify its own code, its own internal structure.
Hold on, are you saying this AI could essentially redesign its own brain? How is that even possible?
It's a really powerful concept, and as you might guess, it comes with a whole bunch of challenges. The authors of the paper are very careful to point out that self-referential systems exist on a spectrum.
So on one end, we might have an AI that can just tweak a few settings in its learning algorithm, and on the other end, we have an AI that's basically rewriting its own DNA.
That's a good way to think about it. The paper highlights two key dimensions: the scope of modifications the AI can make and the level of introspection it has access to.
Okay, so scope determines how much of its code the AI can actually change, and introspection determines how much it understands about its own inner workings.
Exactly. The paper then introduces the concept of a fully self-referential AI.
What's that?
This would be an AI that could observe and modify any aspect of itself with no restrictions.
Wow, isn't that getting a little too close to science fiction? Is that even possible, let alone something we'd actually want to create?
It's a question that sparks a lot of debate. Even theoretically, there are some mind-boggling paradoxes. If an AI could truly understand and modify its own code, wouldn't it have to be more intelligent than the code it's modifying?
It's like a snake trying to swallow its own tail. It creates a kind of infinite loop.
Exactly. And the paper grapples with this paradox, suggesting that the key might be in finding ways to manage the complexity, to create systems with safeguards and constraints that prevent them from spiraling out of control.
So like giving our AI programmer a set of safety protocols and ethical guidelines, making sure any self-modifications are beneficial and don't have unintended consequences.
Exactly. We need to carefully consider the risks and develop really robust mechanisms for controlling the AI's self-modification abilities.
It's a fascinating but kind of scary thought.
Yeah.
But realistically, are we even close to creating AI systems that can modify their own code in a meaningful way?
We're still in the early stages. While LLMs have shown amazing abilities in code generation and comprehension, using those abilities for self-modification is a huge leap.
So it's still more science fiction than science fact.
For now, yes.
Yeah.
But the authors argue that it's a direction worth exploring. It could lead to AI systems with levels of flexibility and adaptability we've never seen before.
Imagine an AI that can not only learn from experience, but can actually change its own structure to become a better learner.
It's a powerful idea. It highlights the potential of self-referential systems to completely revolutionize AI.
But before we get too lost in these futuristic possibilities, let's bring things back down to earth for a minute. We've covered a lot of theoretical ground, but what's next? How do we turn this theory of Socratic learning into reality.
The paper ends with a call to action. It urges researchers to focus on developing practical implementations of Socratic learning, especially using language games.
So it's time to start putting these ideas into practice.
Exactly. They highlight the need for more research on designing those robust and aligned feedback mechanisms, ensuring coverage across different language domains, and addressing those alignment challenges, especially for self-referential systems.
So a lot of work ahead, but also a lot of exciting possibilities.
Absolutely. This paper is more than just theory. It's a roadmap for a whole new era of AI research, one that embraces the potential of language learning and self-improvement.
And it's a reminder that we're not just building machines, we're shaping the future of intelligence. And that comes with a huge responsibility.
Well said. It's a future that's worth thinking about, debating, and ultimately shaping together.
And that brings us to the end of our deep dive into the fascinating world of Socratic learning with language games. We've explored a lot of ground, from the basic principles of self-improvement to the power of language games to the mind-blowing implications of self-referential systems and the ethical questions that we need to address along the way.
We hope this deep dive has sparked your curiosity and inspired you to think more deeply about the future of AI.
We'll be back next time to explore another exciting topic at the cutting edge of science and technology. Until then, thanks for joining us.